Hello students, welcome to the IMS Gate Academy. So now we see the session called quick revision through PYQs on subject computer organization architecture. So we have conducted the series of the gate score booster session, most of the subjects, in which most of the important topics taking into some questions, and we had a discussion on that, correct or not. Now it is a time to revise one more time, we'll spend good amount of time. I have collected the very good questions which are like previously asked papers only, which are asked in previous year gate paper. So through which we'll try to revise the most important topics of COA. Okay, we'll start from beginning. So eventually we'll try to cover the most of the important topic, at least in terms of formulas and their important statement. And also we'll look into this gate questions. The questions which I have selected from the previous year paper, really good questions we can say, because a lot of understanding we can do with the question. So one thing always to understand, some of you might have solved many PYQs, some of might not solved also. I am strongly recommending at least 15 to 20 years of the previous year gate questions from each subject you must practice. So must practice. If you already done, fine. If it is not done, at least some more papers you try to attempt it during the days along with your full length mock test. Because this PYQs only main authenticate questions we can say, through which we can understand the what type of questions you want to test in the paper. Okay. So now let's begin the session. So I hope my voice everything is clear. Let's continue it. Okay. So first let's see the syllabus, the things which I am going to discuss here. Okay. The syllabus, if you see this, just I am going to the topic wise. In the first topic, so we'll focus on fixed point number representation, followed by floating point number representation and also number arithmetic. So the topic names data representation, number arithmetic, you understand. Actually, as per the gate syllabus, if you see, these topics are mentioned as part of the digital logic design, but still I want to cover from the CO point of view only, okay, because the major important thing to be noticed on this floating point number representation. Okay. So I hope this is clear now. Okay, moving on to this. So second topic, memory organization. Second topic will take on memory organization, in which majorly will focus memory hierarchy, main memory and cache memory and secondary memory. So generally secondary memory generally study from the IO organization, but all the memories are less cover into one area only. Okay, this is the second topic you need to be covered. From this third topic, if you see instruction set architecture and instruction pipelining. Instruction set architecture and instruction pipelining. Here majorly machine instruction formats, various addressing instructions, so their format will observe it. Then followed by instruction encoding will observe, architecture supports like you can understand, like 2 or more addressing instructions, so that part will observe. Instruction executions, like what you can understand, if you take any type of instruction, so what is the steps and what stages are involved during its execution. The most important topic, please understand, from this topic is instruction pipelining. Most important. Every year one question will be there, like, so if we verify the previous year gate questions from this, so one question definitely will be there from the instruction pipeline, that is a 2-mark question is possible. 2-mark question is possible here. And you cannot believe it, from this topic, 2024 paper, 4 marks they have framed it, 2 questions of 2 marks. So 2 questions of 2 marks are framed from this topics only now, 2024 gate. So from instruction pipeline 2 marks. Now from this, the chapter or topic, if you name it, the 6 marks have been framed in the last year paper. Therefore this chapter is much important. All my dear students who understand, the computer organization architecture we should not ignore at all. It is mandatory subject we need to study. because average marks which we can expect it from this subject is 9 or 10 marks possible. No surprises if we make it 11 or 12 marks also from this subject. Yes, quickly all of you try to comment it. So we'll discuss the things in a proper manner. Okay. So next topic, control unit design. So majorly you have to focus on this basics like micro operations, like various micro operation, like if you take it fetch micro operation, like fetch operand micro operation, interrupt, like this various micro operations. Some basic related questions can come up. Control design techniques, we have a lot of example you see hardwired control unit design. So micro programmed, nano programmed, like even micro program we have vertical and horizontal, right? But from the past 10 to 15 years papers, if you observe, there was no question from this area. From basics we are seeing either 1 mark or 2 marks is possible in this area. The final IO organization, majorly you just focus on DMA controller, it is much important. So 2 marks question is possible from this topic. 2 mark question is possible from this topic. I hope everything is clear. Okay. So we'll move on to the first area. That is data representation part. We'll observe it. So just a minute. Just 1 minute. Yes, those who are watching, try to share the link among your friends so that they also can join. So together, all together, we'll try to revise the maximum things from this subject. So it is going to be definitely help you a lot. And one important things I am going to share you shortly. Okay. So how this revision things we are planning, that I am going to be discussed. Okay. Now first we'll moving on to the data representation. We'll move on data representation. Okay. So generally, as we know, data. Okay. So this data, understand, please understand. Okay. So this data is classified into 2 types broadly. One is, you understand, numeric data. So non-numeric data, isn't it? Non-numeric data. Like any text or symbols are non-numeric. So numeric data. This numeric data is again further classified into. So one is a fixed point. One is a fixed point number representation, we can say number representation. The second one is a floating point number representation. Isn't it? All of you, right? Floating means what? The decimal point is not fixed, it is moving across a digit. In case of fixed point, the decimal point is fixed. This fixed point number can be again integers, isn't it? Integers and fractions. For integers, a decimal point is fixed rightmost side after LSB. For fractions, leftmost side decimal point is fixed before MSB. This is a MSB bit, this is what LSB bit. For integers, rightmost side, for fractions, leftmost side. But this point is fixed, But in case of floating point number, please understand, it is not fixing, it is moving across the digit, isn't it, like this, see? So 123.45 like this, The decimal point is moving across the digit. The dealing with the floating point operations requires separate mechanisms. The way you treat fixed point integer cannot be extended for the floating point area. We have to be separately dealt. Some of the architecture, if you observe superscalar architecture cases, separate CPUs are used. One CPU for integer operation, other CPU used for the floating point operation. But basically most of the personal computers are designed with a Van-Neumann architecture. Van-Neumann architecture having the only one general purpose processor, which can be able to perform the both integer and floating point operation. But modern architectures, you see modern architecture supporting multi-core processors. I am talking in a single core system itself, this can able to manage fixed and as well as floating point number. For the gate point of this is important, 2 mark question can be expected in this area, please observe now. So in this area, so again 1 to 2 marks is possible in this area also, happened several times. Okay. So this in fixed point number can be unsigned numbers. So it can be what? Signed numbers, as we know. This floating point number can be again, it can be so unsigned and signed. So unsigned cases, no representation for a sign of a number. So sign we are not representing. In case of signed numbers, we have to represent either positive or so negative sign we need to be represented. Okay. So this is a major classification. So one by one we'll move on. So first fixed point number representations. Okay. Fixed point number representation. Here are 2 things we need to see. One is integers, isn't it? Integers, as I mentioned, integers. And second is a floating point number, fraction, right? Fractions. So fractions, integers and fractions. But in this case, what you have to notice, please understand, just only try to know the range of the number here. What is integer number range? Can you tell me if I take n bit number, n bit binary number, if you take, what is the range? Can you tell me, all of you? 0 to 2 power of n minus 1, this is a range, please. Nothing to be changed here. Fraction 0 to 1 minus 2 power of minus n, where n is what? N bit binary number. Yes, all of you, those who are watching, try to comment it. These are the ranges, right? Value expression if I take, like any number system if you take, they have value expression followed by what? Range will be there. This is a range for integer, this is a range for fraction. So these are the 2 things need to be noticed from, nothing else from this this representation here. Okay. I hope this is clear now, everyone. So few things I mentioned here, Okay, you see now. In unsigned integer range is what? 0 to 2 power n minus 1. Unsigned fraction range is n between 0 to 1 minus 2 power minus n now. So unsigned sign magnitude notation with n bit, 1's complement n bit and 2's complement range with n bit. These are very much important things you should notice. So like this is 2 power n minus 1, so you can put it bracket here to here like this. As we know, sign magnitude 1's complement both are covering what? Same ranges, where 2's complement has extra range for the negative numbers, right? So these are these 3 techniques we have, right? Sign magnitude 1's and 2's complement, 3 techniques we have or notations we have to representing the signed integer, isn't it? Integer can be signed or unsigned. These 3 notations we have for representing what? Signed integers. Am I right, all of you? So these are the ranges. So you need to be noticed here. That's it, like based on the ranges, sometime questions asked here in this area. Okay. So coming into the point of floating point. Okay. This floating point number, please understand, floating point number has majorly 2 parts now. First part is what? Signed, signed fraction or significant mantissa also you can say, mantissa we can call like this. The second component is what? Exponent. Every floating point number has 2 components, please, mantissa and exponent. So mantissa also called what we can say, signed fraction also we can tell. signed fraction form also we can represent, or significant also we can say, significant. So significant also we can tell now. Okay. What is the exponent defining? It is a relative position. Please understand, it is defines a relative position of the decimal or binary point, isn't it? Decimal, if you are using binary point exponent defines. Everyone, am I right this one? Okay. So now see, every number, please observe now, every number, any number if you take in a floating point number, any number, okay, any number has to represent into what? So m into r power of e form, isn't it? This only format. This is a mantissa. Mantissa can be signed, unsigned or signed, correct or not? Plus or minus sign, right? So as we know, mantissa can be what? Integer form can be represented, and fraction form also can be represented, isn't it, all of you? But most of the practical cases, fraction form only there now. So this exponent can be, again, it can be unsigned, isn't it? It purely unsigned can come, it can be signed also, right? Exponent can be signed also, as we know, right? So example, suppose one number I am giving 625.4321 assumption, this number is there. Either this format you represent 0.6254321, okay. This point shifted 3 times left to shift, nothing but base of the system 10. The bigger base of the system is what? 10. So 3 times you shift like this, you write it. So this number is what? This is mantissa, isn't it? This is the base of the system. This is what? Exponent e small e. Exponent what? Small e. Or else you can also convert like this, also can be expressed. It is not this format. Now 6254321 dot into 10 power of, so minus 4 also you can write. This we called simply mantissa, this base of the system, or this is the exponent. You see now, mantissa can be integer or fraction form. Integer, this is a fraction form. Exponent can be unsigned or signed, meaning what? Either purely unsigned but signed, but both you want to sign nothing, but it can be positive or negative. So better I can write it, I can just mark it only signed, because it is sometime coming positive, sometime coming negative. Exponent is a signed integer, it can come positive sign, it's negative sign, isn't it? This is the expression, isn't it? This only expression, correct or not? This only every number you have to express this format only. I hope you studied normalized floating point number, correct, or normalized floating point number. Some of you, can you define what is a normalized floating point number? What is a normalized floating point number? Yes. What is a normalized floating point number? Suppose example you take number 0.039 is there into 10 power of suppose 6 number is there. Somebody represented this number. So is it in the form of what? M into r power of e form? Is the form of floating point number representation, this given number? Absolutely yes, correct or not? Somebody written some number like this 0.0039. So 039 into 10 power of 7 written. Are these two numbers same or a different number? Hanu Ahmad and Prabhava. Yes. Tell me. These two representations are same or different? Required response, everyone. These two numbers are same, correct or not? So some 0.39 into 10 power of 5 also can I write? All three numbers are same, correct? All three are same, isn't it? All three numbers are same, but you know, please, which is a feasible to representation? So this is a feasible to representation, meaning when you start padding zeros, like there is a the number can be represented multiple ways. This number can be represented multiple ways, we can represent it. Therefore, try to eliminate or remove the leading zeros from the mantissa. This concept is called normalization, process of elimination of the leading zeros from mantissa. Meaning we are saying that mantissa must start with what? Non-zero digit. This is a unique pattern I should represent. So this we called normalized floating point number representation, we can tell this part. If it is other than decimal, if it is a binary number, mantissa always start with what? 1. If it is a binary number, mantissa always you have to start with 1. So therefore, so little modifying this value expression. So m cross into r power of e is there now, isn't it? E is there now. This m can be most of the cases what? Fraction. So I am writing like this, fraction form into r power of e form is there. So this m is a signed one, plus or minus point m, like this I am writing, no, this one into r power of e form I can write it. So this I can put it like a value expression I am writing, no. So minus 1 whole power of s I am writing, so point m. So point m, base of the system we are dealing with what? 2, dealing with the 2. So now e I am expressing capital E minus bias form I am writing. Some of you can tell me what is this bias now here? What is the bias here? This is our standardized value expression for floating point numbers also can tell. Value expression equal to, so minus 1 whole power s into point m, fraction form mantissa I have taken, into 2 power e minus bias. What is this bias? Please understand, as I told you, exponent is coming signed, correct or not? Exponent is coming signed, sometime plus, sometime minus, right? Yes or no? So what happens, you please understand, whenever exponent is a negative form, signed form is there, during floating point operation, when you do power alignment, if the signs are involved, there is a truncation problem to the data because limited registers we are using. So therefore, if you express this all signed numbers into unsigned format, so what you can say, like just we can simplify the operation. It is not going to avoid the problem. We are going to minimize the operations. Thus complexity can be reduced when I am dealing with what unsigned instead of signed one. So therefore, in a practice what I will do, whenever small we are storing in the computer register, add some excess value. That excess value we are calling as a bias. After adding this one, this becomes a capital E. The capital E is nothing but, you know, biased. We called biased unsigned. This became completely unsigned. Unsigned exponent it became now. So this is what original or true exponent. Original or true exponent. It comes from the user. Original, whatever exponent comes, for this some extra value we add it. That extra value is called biased value. Therefore, what if this become positive? This become positive. Now question arises to make it like, no sir, when exponent comes from the user, negative or positive comes, we have to make them into always or positive side only. How much bias I should add? Some of you can you tell me how much bias has to add? Suppose you understand now E is here, E can negative or positive comes, right, small e. If it is a negative, nothing but 2 power of k minus 1 comes. If it is the best case 2's complement representation if I use it. So plus 2 power of k minus 1 to minus 1, isn't it? Sorry, this expression, isn't it? Is a range of 2's complement number range or not this one? Everyone respond. If I ask you in a k bit number, if I take, is a 2's complement range or not? 2's complement range with a k bit number, isn't it? Okay. So this is negative number, isn't it? So this negative number entirely I have to convert into positive side. Therefore, what I am trying to do, so k minus 1 plus, for this also I am adding 2 power k minus 1. So less than or equal to, now plus. So this will be what, 2 power of k minus 1 and plus bias I am adding 2 power of k minus 1 now. So these two terms are get cancelled. So this became what? This became, no. So this becomes what? So this, if simplified, 2 power k minus 1 comes. This I am modifying as capital E now, capital E. For small e we added bias. This is a bias, please understand. This is a bias value we have added. So I am standardizing. So bias value we should add it what? 2 power of k minus 1. Dear my students, there are two set of questions can be seen in the gate paper. One is conventional based floating point number representation. Other is what? Modern approach, nothing but IEEE 754 format. There is no issue with what? IEEE 754 format. Very, very easy that one, because every field is fixed. Every field is fixed simply. But if it is conventional based question comes, we must aware of it, how much bias I should add it to make it this exponent become positive side. That is nothing but bias value 2 power k minus 1 I should add it. Is it clear all of you? Please do respond. Is it correct? The value is correct, everyone. Bias value. So therefore now come to the point here. When I write it, small e. So now see. So now what is small e? Small e is nothing but what? I have to remove capital E minus what? Bias. Capital E minus bias only. Isn't it now? See, capital E minus bias. Yes or no, this one? Base 2 into 2 power E minus bias I have written. So by default this expression we called explicit normalization, we called it. Explicit normalization we called. Why sir explicit normalization? Sir, this number is what? Binary sir. It mantissa must start with, isn't it? This mantissa must start with. So must start from what? From what? 1 only. Is it? First bit should be what? 1. The first bit should be 1. Yes or no, all of you? The mantissa should be start with what? 1 only should start. Why sir? Normalization concept. Because we want to eliminate the leading zeros from the mantissa. I mean, a binary format, if you remove the zeros, nothing but rest is what? Started with 1 only, right? Started with 1 only. Suppose mantissa has a 8-bit number assumption now. So now my numbers have to start like 0, 0, 0, 0, 0 like this. Sorry. First number cannot be 1, 0. So this should be like this, This is a first number, first mantissa number. So second mantissa number is like this, 0, 0, 0, 1. Third mantissa number is like this, 0, 0, 0, 0, 0, 1, 0 like this. Like this, 0.11111111. This is the last mantissa number. This is the last mantissa number. Okay. You should also aware of it, the pattern which we are able to, which are writing for what? Mantissa. Now, so every number if you see 1 is there now, every number 1 is there, correct or not? Every number first bit is what? First bit is what? 1 only. For every number first bit is 1. So what simplification can be done, So later sometime, some years you understand now what a suggestion came into picture. This value expression equal to minus 1 whole power s 1 kept outside, base 2 into e power 2 power e minus bias is written, nothing is changed, only 1 kept outside. This we called implicit normalization, we called implicit normalization, we can call implicit normalization. So what does mean this one keeping outside? Meaning just assume implicitly 1 is present, but don't store 1 explicitly in the register. Just assume that 1 is there. For the calculation 1 you can use it, but don't store 1, because whatever mantissa number you take, first bit is 1 only now. If you keep that number is one side, what happens, in that position 1 extra bit you can store it. This we call precision. Therefore, what I can say, implicit normalization giving more precision than what? Explicit normalization. More means 1 bit precision is giving. Is it clear all of you? 1 bit precision we can get it through what? Implicit normalization compared to what? Explicit normalization. Implicit normalization giving more precision means what? 1 bit. In that 1 bit you can store 0 or 1. Now after keeping 1 outside, in a suppose n bit mantissa has 8-bit number, first bit you can store 0 or 1, no restriction now. First bit you can store 0 or 1, no restriction. Reason is that 1 is already kept outside, assume that 1 is present. So that m bit, suppose 8-bit mantissa you can able to store 9-bit data. The precision understanding, what is the meaning of precision? In a 8-bit register, 8-bit of the Mantissa, we can store 9-bit data. This is a basic idea, please. Because implicit normalization we are using in where? IEEE 754 format, isn't it, all of you? Under IEEE 754 format, we are using what? Implicit normalization only. So expressions are fixed here, correct or not? Implicit, explicit. The limitation of the conventional or fundamental or traditional floating point number representation, you understand? Can I represent 0 here? Please understand and tell me now. Under normalized, either implicit or explicit, can I able to represent the 0? Answer it, answer it, answer it, all of you. Under this two mechanism which I mentioned, after normalization, the normalization can be implicit or explicit. Do we have a pattern for representing 0? I am asking now. Can I represent the 0? I need answer from everybody. Very important question, very important question. Can I represent the 0? If it is yes, tell me how can I represent? What is the pattern I have for representing 0 here? Here only I am talking, this traditional floating point number representation which has Mantissa, exponent and bias components like this. What is the minimum number you are representing, sir? 1 here, nothing but what is the minimum number, sir? When I evaluate decimal, this value becomes what? 2 power minus 1 or not? 2 power minus 1 or not? So value expression minimum if I take, so minimum positive number like I am taking S as 0. So point m is what? This m value is what? 2 power minus 1 into 2 power e. E capital, let me take 0. Bias, let's take some bias is their assumption now. So minus 1 is 1. So 2 power of minus 1, 2 power minus 7 into 2 power of bias. Let's take bias value 32. So 2 power minus 1 into 2 power minus 32. This becomes 2 power minus 33. So when I consider bias as a 32, so when I am expressing the minimum number which you can represent in this one is a 2 power minus 32. 0 is not at all possible to represent here. That's what underflow problem, overflow problem, rounding off problem. These are the problems which are associated. To resolve this one, understand, to resolve this one, IEEE institution has given a standard. Its standard number is 754. Standard as given for representing the floating point numbers, floating point number. So this given under 1985. After 1985 onwards, most of the architectures, all the architectures are following. So which format ma? IEEE 754 standard only. And it is giving the programming like program portability. The code which you written one architecture. So before 1985, if you design the IBM architecture, floating point operation cannot be adaptable to other platforms. So it is not possible because each case's Mantissa pattern, exponent sizes, bias is varying, correct or not? IBM architecture you take, other architecture you take. So therefore IEEE institution has given that standard. Nobody from this point of view, nobody should follow your own standardization for representing the floating point number. All should follow this standardization only, IEEE 754 number only. So that the code which you written here you easily can be moved for other platforms also. So this standard has given for one is single precision. One is what? Single precision, please understand, single precision. So we called a 32-bit number can be represented, isn't it, all of you? The second one is what? Double precision, isn't it? Double precision now. So double precision having what? So 64-bit. Third one is what? Extended precision also, extended. So extended precision also we have. Extended precision I have 128-bit long. 128-bit long also we have. Am I right, everyone? Single precision, double precision, extended precision. In the gate question, please do understand, everyone, it is not required to specify always 32-bit register. If they mention single precision, you should understand this is talking about 32-bit number only. If they say double precision, you should understand 64. By the way, you will not expect the question from double precision. You will only expect the question from what? Single precision. From the past 34 years, if you observe, There was no any single question from this one, only from 32 bit only. So now just a pattern we will understand, just pattern we will understand now. Suppose if I take single precision, if I take single precision if I take of 32 bit. In this case fields are fixed, please understand, fields are fixed. One is sign bit, 1 bit sign bit, and exponent capital E 8 bits are fixed, and mantis are 23 bits are fixed. Am I right all of you? No need to give in the question also, you should know these values. Sometime anyway they will give it, sometime most of the time they will give the values like size of the mantis or size of the exponent, but if it is not given also we should know this one. Okay. So now understand, this is what unsigned number, correct, or unsigned number is an unsigned number. What is the range of this one? Can you tell me what is the range of E? 0 to what? 255 possible, is it? So 0 to 255 this value of E. Now this single precision giving a provision to represent, please understand, 0 can be representable, very large number, infinite number also can be representable. Smaller than smallest number, larger than largest number can be representable in this format now. I will show that what is the lowest number can be representable, what is the highest number can be representable, we will observe with this one. The range is what? 0 to 255. Sir, to represent the 0 or infinite, some values of mantissa exponent are reserved. Which are reserved? So now you understand, E equal to 0 and last number 255, it is reserved, please understand, you cannot touch for the normal values, reserved for special values. So reserved for special values. Special values. Now you tell me, so after removing these two numbers, what is the E is possible now? Capital E is range from what? 1 to 254 only. Isn't it all of you? 1 to 254 only. Am I right all of you? So the relation we know, capital E equal to small e users, from user it will come, some bias we should add it. Now tell me all of you, if this exponent field is 8-bit number is there, what is the bias I should add it? Yes, what is the bias value I should add it here? Because anyway unsigned format only we are storing, unsigned format only storing, from user it can come signed number, positive sign or negative sign can come. What is the bias I should add it? Bias value, tell me all of you. Response required all of you. Yes. What is the bias value here? Prabhava, Hamad, Prabhava saying that 254 bias I should add it. 254 bias value. As per the conventional things, so what we proven that bias value must be 2 power k minus 1, where k is what? K is the exponent field size, isn't it? My field size are like this, isn't it? My field size are like this. So where, sorry, here. So now field size of the, if you see 32-bit pattern, nothing but, if I take 32-bit, 1 bit goes for here, followed by exponent k bit and mantissa will be there, right? So 1 bit here is how many bits we said? 8 bit, here is what? 23 bits are there. As a conventional point, bias is 2 power k minus 1, this 2 power of 8 minus 1. So 2 power 8 minus 1, nothing but this is 7, 128 bias I should add it. But you might have studied IEEE 754 single format, please understand, single format, bias value 127 you might have studied. Why can't 128, why it is, why can't 128, why it is 127? My question is clear? As a conventional property, this must be 128 because we have before 1985 onwards, we are preserving this whenever 8-bit field you are using. So a bias you should add it 128. Please understand, if the larger the bias, If larger the bias comes, smaller the number you will store it, because bias smaller the positive number you will store it. If smaller the bias, if it is there, larger the positive number can store in the register. Now naturally 128 we can think, but you might have said 127 is there. Why 127? Come to the point here. As I told you, 0 and 255 reserved. Available numbers for E, we have available numbers from E what? 1 to 254, total 254 numbers only there. But also I have relation. I have relation E equal to small e plus bias, correct? This only relation we know, right? Yes or no? Now maximum, if I ask what is the maximum capital E possible? Maximum capital E possible is what? 254, isn't it? Maximum capital E. Now what is the best relation I can make it to balancing these two numbers? Because if bias is large, positive value E has to come low. If E is large, bias will be less, you should add it, isn't it? To make it balance, how much I should divide? Should I divide E value should be 127. So bias also should I make it 127? Makes sense here, all of you? Normally this field says 8-bit number is 2 power k minus 1, 8 minus 1, 7, 128. There is no doubt on this one now. There is no doubt on this one. But the point is that two numbers are already reserved with. I do not have more space here, correct or not? That is the reason to make it this relation. Like 255 is the maximum possible 250, 254 possible. Exactly I can divide off. When I divide off 127, 127 comes. Now my bias is fixed now. So no need to given in the question 127, it is fixed here. 127 is fixed. So no need to mention in the gate paper ma. This is not required to mention in gate paper. Simply you should understand 127. Why sir? Off I given here. Therefore from user, now one more point now. So what is the capital E equal to small e plus bias? Small e plus bias now. So what is the minimum E possible? Minimum capital E possible, tell me. What is the minimum capital E value? Isn't it 1? This is a minimum 1? Minimum 1 or not? Minimum 1. What is the bias? We fix it 127 now. So what is the minimum E has to make it to make the, so I have to take, what is the minimum E I have to take so that relation holds good? Isn't it minus 126? Minus 126. So now my bias is not going to be changed. Bias is fixed 127 only. Yes. Now from user please understand, small e, minimum small e comes from how much ma? Small e from user, what is the smallest small e? Small e can come from the user. Respond, minus 126. What is the largest value? 126, 127 sir, 127 now. Is it? 127 now. Actually number is like this, no? 2 power minus 126 less than or equal to E less than or equal to 2 power 127 now, please. This is a number, range of what range of small e, it has to come from user. Amma, this number is it? Are you thinking a small number? It is smaller than the smallest number you should tell. 2 power of minus 126, nothing but 1 by 2 power 126. Smaller than smallest number which you can give to represent, and a larger number 2 power 127 large number also can give to store it in this 32-bit register. From user he can enter it. 2024 gate exam 2 more question I asked, what is the pattern I should have to store the largest positive number? Tell me what is the largest positive number I can store in the IEEE single precision format? Answer is front of you only. Tell me what is the largest positive integer can be stored in the IEEE single precision format? Respond. Required response everyone. Isn't it this the largest number? 2 power, yes. Can't you expect next year, some other year in the future, they will ask this question or not? You tell. Some of their, till now not asked, some of their can ask this question or not? Sum up there, can you expect this is a question can ask, what is the smallest number which you can store into IEEE single precision format? So, but you know, in the GATE question of 2024, they did not give options like this. They given a fields of mantissa field, exponent field. Now tell me now, if small e comes 127, what must be the capital E? Respond now. So in this moment only I am asking, if small e from user say 127 is a, you tell largest number which you can store 127, sir. So what is the capital E, how to store it? Can you tell me? Answer it, answer it. Capital E, how much I have to store in the register? Capital E. Small e from user came 127. Now capital E, how much I have to store? What is the capital E should have? Required response, all of you. Capital E should be 254. Capital E is because small e plus bias, isn't it? 250, 254. This only right. Sir, this number is positive or negative, sir? This number is positive or negative? Positive. So S value should be what? 0, sir. When S is 0, sir, exponent should be this full. What is the mantissa should 0 now? Because complete exponent is there. Do you have any mantissa fields here? When you want to store this number, mantissa 0. So this your answers only. But they are not in decimal. They are in binary. That's it. You have to select it. 2 mark question. 2 mark question. Yes, yes. Very good, very good, very good. So therefore 0. So to represent the exponent field only storing, we are not storing any mantissa. So mantissa going to be 0. That was one of the question. For this we can answer it like this. Yes. So I hope this format is clear now. I hope you understand why bias is what 127 here. Why bias is 127? Is it clear? Why bias is 127? Because maximum is possible 254. I am balancing this to, because if you take higher value, it has to reduce, isn't it? You can understand, no? If you take 128, it has to store 126, you have to store it. It is directly impact on the user exponent value. So that equally balanced here. Therefore from user, so this a range can come, this a range can come, we can store it now. This is a format of the single precision format. Suppose second one I am taking as a double precision format. Double precision format is what? 64 bit. So this 64 bit is divided, like, you know, sign bit is anyway 1 bit will go. So exponent will take 11 bits, it will take 11 bits. This will be, mantissa will be 52 bits more. This is fixed. Future exams, we may just expected like a field size also, because never touch. If they touch, at least basics can given. So 11 bits are given for this one. With this 11 bits, capital E possible 0 to 2 power 11 minus 1, 2047, isn't it? 2047 possible. Again to represent some numbers, so 0 and 2047 is what? Are reserved. These numbers are reserved. Reserved, please understand. These numbers are reserved. These numbers are reserved. Am I right, all of you? These numbers are reserved. So therefore, small capital is possible from 1 to what? 2046 only possible now. As we know the relation capital E equal to small e plus bias. Small e plus bias. So now maximum capital E possible what? 2046. To make it balancing, what is the distribution I should do it? Tell me. What is the bias I should do? What is the capital E? Small e can come from user. Yes. Maximum, see here only maximum this is possible, correct or not? Similarly, so I want to make it E equal to small e plus bias. So small e I am taking 1, minimum E is what? 1 possible. Now here is this relation I should make it. What should I write it here? This one. Namana, Hamad. So 1023 plus what? 1023. Now bias can I say now? Under double precision bias is 1023. Single precision 127 now. Isn't it? Now this bias is going to be 1023. Now minimum value minus 1022, is it not? Minus 22. Very good, very good, very good. So this I can make or not now? From use of small e can come, ranges from 2 power minus 10222. Now understand 2 power of 1023, isn't it? So this number is, you can say, smaller than smallest number, larger than largest number. Approximately this number I can tell, 10 power of plus or minus 308, this big numbers and small number you can representing. Under 64-bit register, you are representing approximately 10 power of plus or minus 308. 308 means after 10, 308 zeros you keep it. That largest number can be represented under 64-bit. 10 power of minus 308, smallest number can be represented in 64-bit. Similarly, when it comes to your single precision, so number is 10 power of plus or minus 30, if I am not wrong, 34 I think, if I am not wrong, 34. 10 power of plus or minus 34. So number can be representable under single precision, So these are the important things can be observed from this IEEE pattern. So now IEEE pattern, like example, if you take it, first one single precision. Okay, if I take single precision, so single precision I given some cases, you might have studied some cases. What are the cases like? So because you have to distribute the numbers, right, some patterns are reserved, right, some patterns are reserved. Let me take sign bit here, sign bit is what, 1 bit here, followed by exponent is what, 8-bit number. So mantissa has what, 23-bit number. What these values are representing, let's understand now. Just through 5 cases we are able to answer it. Case number 1, this bit can be either 0 or 1. Now I am taking if this e equal to 0, full exponent 0, even all mantissa bits are 0. This represents simply plus or minus 0, that's it. All zeros represent 0. First sign bit is 1 followed by all zeros minus 0, like this you understand now. Case number 2, the value can be 0 or 1 if e is what, full 255, and if m equal to what, 0, this represent a very largest number like this. So plus or minus infinite, you can write it. Case number 3, 0 or 1 binary bit now. So now e is from normal number I am taking, normalized number is from what, 254. So m is what, anything, any possibilities. This is called implicit normalization. So implicit normalization formula you know already. Case number 4, 0 or 1. So now I am taking, this is e is 0. So mantissa is not equal to 0. Mantissa has some bits, fraction bits are there. This we call a d-normal number also you can say. D-normal number also say. So this is taking the fraction form it takes. So case number 5, 0 or 1, e is what, full 255. So m has what, not equal to 0, it won't represent, not a number we can say. Some which can understand square root of minus 2, like 0 by 0, like this some numbers are not like 0 by infinity, like this, some numbers which are not, patterns are not representable. So with this combination of the patterns, most of the gate questions can be solvable. We can solve easily. All of you, is it clear? Shall we take some one of the previous year gate questions to attempt it? Yes, all of you. Is it clear? Anybody having any queries? Any doubts are there till this point? Okay. So this all we just I given also in floating point number representation. Value expression is what? Explicit normalization. This is implicit normalization. This is 127 fixed here. For fractional or denormal number representation, like so value expression will be -1 whole power of s. So point fraction only into base 2. So e as 0. So minimum e is what? 1. Minimum e is 1. 1 nothing but this becomes what? -126. This is a smaller than smallest number. Very, what you can say, small number can be representable. Okay. 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 So this also we have observed it. So let's see, there is 2023 gate question. Very interesting question was asked it. Very interesting question. IEEE 754 single precision floating point number, P as given now. P as given. So OX C1850 is given, 5 zeros. Q also number is given, Q. So this hexadecimal number 3F 5C 2E F4 given. Which of the following corresponding to the product of these numbers P into Q represent again in IEEE single precision format only they are asking. So there are two floating point number. Actually they are doing floating point operation, but actual floating point operation, addition, subtraction, multiplication not required to do it. What you can do it answering the question, whenever the number representation is given, get the decimal value, do the operation, again represent it. That is the simplest way you can do it. So previous year questions you observe, addition of the two floating point number, subtraction is given, division is given, this multiplication is given like this, multiplication now. You can tell me now this, you know the pattern, right? When the number is given like this, can I get the decimal value or not? Can I get the decimal value, multiply this, again decimal value you store into what? So IEEE format only, that way we can able to solve it. Let's try with the P. So P is a number, hexadecimal number is given, C1850, right? C1850. So let's write a binary. So 1100 0001 1000. Okay. Followed by all zeros like this. We have zeros, right? Zeros. Total number is what? 32-bit number. The first bit is what? Sign bit. So 3 plus 4 7 till this point, isn't it? So you can 3 7 8. This we called exponent, isn't it? Exponent field only. So remaining bits are what? Mantissa, isn't it? Mantissa only, all of you, Mantissa only. So sign bit is equal to 1, sign equal 1, exponent of field is what? Exponent 100, so 00011. Can you please tell me what is the decimal value of it? Everyone participate, try to be active, tell me the value. So all of you please understand, you should know the at least 8-bit number, bit position you should know. So that if you know these bit positions, problem solving on computer architecture, problem solving in digital logic design, problem solving in computer networks also going to be easy for you. 8-bit number, every bit position you should know. So this value is 1, 2, 4, 8, 16, 32, 64, 128. So 128 plus 3. So 128 plus 3, 131, isn't it? 131. No? 259? Where is it 259? So Prabhava, check. Hamad, check it. 1, 2, 4, 8, 16, 32, 64, 120. This is 128. 1, 2, 3. Isn't it? 1 and 2. 131. Am I right, everyone? Namana, are you there? Yes. So now E we have seen, it is a normal number. So normal number, we know the value expression, implicit normalization, -1 whole power s 1.m. So base 2 into e power of 2 power e minus bias is fixed 127. No change on this one. No change on this, right? So value expression if you take -1 whole power of so s value is what? 1, negative number 1. So 1.m, m is what? 0 into 2 power of e value 131 minus what? 127 now. So this value, p value, simply p value I am taking, p value minus of, so 1.0 into 2 power of what is a 4 only, correct or not? 4. Let it keep like this, or else simply I can tell this -16 only answer if I want to say. -16. Hello, -16 only. Now look for the q. Q is, what is the q value given? Just a minute. Right, this q is given, correct or not? Now if I write it binary 0 0 0 1 1, f means what? All ones, 5 0 1 0 1, 1 1 0 0, and 2 means what? 0 0 1 0, 1 1 0, 1 1 1 1, and 0 1 0 0, right? Now by looking at this number, now fear is coming, correct or not? Sir, this many numbers are given. Suppose if you look at this one, so s bit is what? 0 only. So now E3 and 4, this is still I can take this 8-bit number capital E. So now what is the capital E value? Can you tell me? 0 1 1. So 4 ones 0. What is this capital E? Suppose you take 1 2 3 4 5 6 7. When 7-bit number high E, that becomes 127. 127 minus 1, this weight is what? So this value is 126. But sir, how to evaluate this big number, sir? Fractions, correct or not? We should get surprises here, like, you know, what? How to evaluate this big number, right? Then we go back and see, like, immediately will not get any doubt. You should get doubt here. Doubt you should get. So, okay, this evaluating decimal takes a lot of time. No, how many powers? 2 power 1, 2, 4, 8, 16, 32. How many powers I have to evaluate? So something, maybe there's something we have to observe again question now. P, Q is given. So Q has a number like this, okay, number is there. Can we see options? So most of the options, you know, 5C, C2 EF4, C2 F4, C2 F4, C2 F4, C2 F4, okay. So something Q value is common, correct or not? They are not touching at all. So they are not touching, no, see, C2 F4, C2 F4 is there. This you should get a clue. Okay, I should not proceed. I mean, I should not evaluate this part. I should not evaluate this part. Sorry, this part. This part I should not evaluate. Better I'll keep it like this only. So with this respect, we got 126. Value expression I am writing, value expression. -1 whole power of s 1.m mantissa into 2 power of e minus bias is 127 now. So s value is what? 0, 1.m. Better you write m as it is only. M is from, you know, this one, you know, this 101 nothing but what? 5C, 2EF4 I'll write. Directly I'll write it. 5, I'm keeping as it is. 5C, 2EF4. So let me, it is still hexadecimal number only, but I am writing later I can convert into 2 power of e is what? 126 minus 127. So -1, this value is what? Positive only. So 1.5C to EF4 into 2 power minus 1 came. Isn't it? 2 power minus 1 came now. This is 1 point m something came, correct or not? This is a q value. What is the p value now? What is the p value, tell me? So 1.0 means 1 only na. This mantis are simply 1 only na. All of you 1 only na. So let me multiply these numbers. What is the interesting thing, I can get it now. So p and q I am multiplying. So minus of 1.0 into 2 power of 4 only, 2 power 4 only, 2 power 4 into 1 point this number 5c 2ef4 5c 2ef4, right, into 2 power minus 1, right. Amma, this is like a 1 point mantissa, isn't it? So 1 point mantissa is there, correct? Now this is number is nothing but 1 only na. 1 into this number, what I'll get, tell me ma. This number is entirely, no, this is, so this m is what, 0, mantissa 0, nothing but 1 only there. 1 into this number is what, this 1 point m only, can get it or not? The results. So now here minus and plus, minus only I am writing. So simply 1.5c2ef4 into this exponent, I should add it. This becomes 3. Please respond here in this moment. Is it clear, all of you? This only result? This only result or not? So now mantis already there, right? Yes or no? Mantis already there now. Mantis already there, correct or not? Can I check this 5c should be there? So 5c should be there. Is there options like this? 5c 2e4. Okay, 5 also matching, 5 also matching. So first exponent field I need to find out. So exponent field I need to find out now. This is clear now. This part is clear now. What is exponent? 3 only now. This is small e or capital E. This 3 is small e or capital E. Now this s bit should be what? 1, because negative number got s value. Now capital E equal to what? Small e plus bias I should do, isn't it? Small e is what? 3, capital E, bias is 127, 130 you have to store it. So 130 you have to store capital E. How to write 130 in binary? 128, 64, 32, correct? 16, 8, 4, 2, 1, isn't it? 3, 4, 4, 8-bit number. This is a number we got, correct? All of you, is it clear now? The storage will be, what is storage? The storage, suppose when I want to store it in this 32-bit register, sign bit is what? 1. Exponent is what? 1, 0, 0, 4 zeros, 0, 0, 1, 0. Now see, here is 5, how to write it? So 1, 0, 1 only I should write it, because we have taken 1, 0, 1 only. Rest number I am keeping C to E of 4 only I will keep it. C to E F4 I am not touching now. So this numbers I have to touch now. This numbers 4, 4. So 1100 C. So 0x C. This value is what? 1. C15, is it? C15, C2 EF4. Do we have C15? Option C15. Yes, option C is right now. See, the gate people, they don't want to consume our time for calculation. Whenever we are going some direction wrong, how you have to understand, not only this question lot of things can be learned from this question, please understand. Not only in the computer architect this question, whatever question is there, whenever you are attempting any question, you are not able to solve 2-3 steps. Maybe calculation taking much time means what? You should get a doubt, something you missed it, your direction got changed it. If the direction approach is correct, within 2-3 steps, so for any question you will get an answer. Maximum 2-3 steps. It won't take you many steps to be evaluated. Maybe some clue might have given, we may be missing that one. We may be missing this one. This should, we should notice this all. We should notice. This way we should calculate So I hope answer is clear. So immediately we'll move for other topics. Other topics will move. Okay. Other topics will move. So one important update I would like to tell you, please, all of you. quick revision sessions, most of the subject we are going to be conducted. Most of the subject we are going to be conducted. Like now we started with computer architecture, next computer network, compile edition, 3F computation, DBMS, C data algorithm, discrete structures. So we are going to planning, but we are not planning on YouTube. Okay, so we are planning on IMS own website only, own portal only we are planning. So what you have to do, you no need to pay any money to join those sessions. So we are offering that gate zero fee programs. So there is a link on the description. Just to click on the description, that link, and register your name. Okay, register your name so that you will get a user ID password. So you can log in, check the schedules, upcoming schedules. You can attend the classes. So live classes next upcoming week. Most of the subject we planned 3, 4 hours, 5 hours like this. We planned it on most of the subjects. So we do the revision through our previous year gate questions and looking at formulas. All the aspects we are going to plan it. So we are planning for along with our registered students, enrolled students, along with enrolled students, even other students also can be join those sessions without paying any extra money. No need to pay anything. No need to pay anything. Just you only enroll what. So this you can see the program name is what? Zero fee program. So enroll for this one. This is one important update I am going to say, because this is the only last session you can say now. Revision on subjects is a last session in a computer architecture for GATE 2025. Remaining sessions are we are conducting our platform only. So all these students who are right now watching, later you are watching COA, you can like that also please understand that also available recorded form also will be available. Suppose example sometime some people may watch this video later after 2-3 days watching this one. In that moment also you can enroll. So recorded from those videos available before the GATE examination, you can watch the subjects and revise those sessions. It is definitely going to benefit a lot. So I hope this is clear now. So and also as I mentioned, so test series plus. So even you have a time, almost we have a 20 days time. Next 10 days at least you can utilize for the attempt in the mock test. So test series plus is offering not only 12 full length test series along with some extra booklets also will be getting last 33-34 years of the previous year GATE questions along with the solutions, having the video solutions. This additional benefit with this test series, and that also discount is reduced, you can see the discount almost 40% the discount is there. So you can enroll, you can take this test series. This is definitely going to be help you a lot. Okay. So now coming to the point, we'll move on to number arithmetic. So number arithmetic, please understand, no much discussion. So do not addition, subtraction, no need to study anything. Only some few important problems, important formulas you should know. One is that what they will test. 1 mark question can be, 2 mark question can be framed in this area. Overflow detection. Suppose when you are dealing with a signed integer addition. So how overflow can be detected? The standardized expressions we have. Let me show that one. Just recall the things here now. Okay. If 1's complement or 2's complement notation are used to representing the signed integer, signed numbers, and then overflow detected one of the following 2 conditions. We can apply 2 conditions, you can verify it. Numbers are of the same sign added. Suppose numbers are same sign, result or opposite sign is there. During the condition, this result in overflow. Important. Suppose 2 same signs are you are adding. Result came opposite. You just declare this is what overflow. But this is not required to verify, because this statement only useful for whenever theoretical question comes. If numerical type questions come, this is not required. It just completely ruled out only. This all not at all required to remember. But theoretical question comes, at least we have to choose whether this is correct or incorrect statement like this. Second condition is that whenever carry in bit to the sign position and out of the sign positions are not same, then also it is overflow only now. But we have a third notation also, right, where we can use sign magnitude notation also. Sir, if I use a sign magnitude notation for representing the signed numbers, if the signed numbers are denoted in sign mag notation, the presence of carry out bit at sign position, carry out came at sign position, that results in overflow. That results in what? Overflow. So just understand this through what you can say 3 rules. So with this one, if a theoretical question comes, we can able to answer it. Let me give one question. Apply this knowledge which I given to statement, this one. Okay. Can you please tell me which of the following operations result in overflow in case of one's complement arithmetic is used? What are the option will produce overflow? So now assume that operand size is what, 8-bit. I am also writing one's complement representation if I am using with 8-bit number range if you see. So minus 2 power of 8 minus 1 minus 1 2 plus 2 power of 8 minus 1 minus 1, that nothing but 128 means minus 127 2 plus 127 is the answer, plus 127. 120. One of the previous year gate question asked here, can you tell me what are the option can result in overflow when they are doing what one's complement arithmetic? Response is required. Be active all of you. There are many things to be discussed, ma. Do not leave the sessions. Like also share the link to your among your friends. Let them join. We'll discuss more things on memory hierarchy and even important things from the instruction pipeline. Instruction pipeline much important. Some what you can say, some observation, very good observations we are going to do it on this part, especially operand forwarding mechanisms. Students generally have a doubt on operand forwarding, like control adjust, branch related instructions. So those things can be observed properly, ma. Yes. So do not require to perform any kind of arithmetic operations. Let's just get the what decimal values. You see whether this results in falling under this range or not. In this manner we can solve it. Amma, in one's complement, what is this number represent? One's complement. No. That is a mistake you are understanding. They said clearly, no. Which of the following operations result in overflow in case of one's complement arithmetic? Assume that size of the operand 8-bit, meaning one's complement arithmetic you are doing. Arithmetic addition or subtraction doing on one's complement means numbers already represented in one's complement. They are not normal numbers, please. There is a mistake of understanding the question. It are not binary, it is not normal binary numbers. They are already in what? One's complement. If this number in already one's complement, what is this value? So just to know, put it, what you can say, one's complement number, if you complement it, what will get? Same number only. But this is sign bit, right? If I complement, this becomes minus 0. This is what? Plus 0. So minus 0 plus 0, can I represent in this range or not? Yes. So therefore there is no overflow here. What is this number it is representing now? One's complement, this number is that. So I have to complement 000, 4 ones. So this number is going to be minus 15, isn't it? This number is what? Plus 15. This result is what? 0. No overflow. So this number is what? Minus 0. This number is minus 0. No overflow. So this is positive number, right? This is a positive number. So this is 1, 2, 4, 8, 16, 32, 64. 65. This number is what? 65. So this number is what? 65. This number is what? 64. Result is 128 plus 129. So this number is plus 129. 120. Can I store in this one 129? Can we store 129 in this one range? Not possible. So this result is overflow. As per the condition also we can verify it. So 0, 1, as per the condition is 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, right. Other number is what? 0, 1, 0, 0, all zeros, like this numbers are there. Now perform addition operation we can try. Now see, so carry in naturally 0 will be there, carry in C in value 0. 1 plus 0, 0, this is 1 only, this is 0. So now see, 1 plus 0, 1, carry out is 0. Sum is 0, carry out is what? 0. Sum is 0, carry out is 0. Sum is 0, carry out, sum is 0, carry out also 0. This is sum is 0, carry out also 0. Sum is 0, carry out also 0, isn't it? So 1 plus 1, 1 plus 1, 0, is it 0 only, isn't it 0? So carry out is 1. So this value is what? 1 now see. These two numbers are, these are sign bits only now. One rule we have in a ones complement. When same numbers are added, result is opposite sign. Result is opposite sign or not? Can you see? 0, 0 same sign, result is what? Opposite sign. So now this indicate what? This indicate overflow or not? Everyone tell me, overflow? Yes, we can verify like this. Isn't it? Suppose my question to all of you, again, these are the options. If I repeat for 2's complement notation, can you tell me what are the options will be overflow? If I repeat this statement again for instead of 1's complement, if I repeat for 2's complement, can you please tell me what are the option may occur into again overflow? Repeat the problem for 2's complement. So now as we know 2's complement range, if I talk, what is the 2's complement range? Minus 128 to what? Plus. So minus 128 to plus 127 will be there. So minus 128 to plus 127 will be there, if I am not wrong. Yes. Repeat, all of you repeat. Test it. What again? What are the options are result in overflow? If I repeat this problem for a 2's complement representation. Sir, same option, sir. So Prabhav is saying that ACD, sir. See, that is a learning. Prabhava is a learning is that we have to verify properly. That's what whenever we are studying something, once you tested something, again you suppose if I change this one, what is the result? Like this we have to keep on verify it, so that many observation can be done now. Okay. So now I am just copying these options so that to get a clarity. Okay. So first option is that, what is the first option? All ones, all zeros, right? Ones, all ones, all zeros. Option B is there, 4 1 zeros, 4 ones, 4 zeros, plus 4 zeros, 4 ones. Option C, all ones, I think, plus all ones, isn't it? Option D is 0 1 0 0 0 0 0 1 plus 0 1 0 0 all zeros, isn't it now? Now these numbers are in 2's complement notation. These numbers are in what? 2's complement notation now, correct or? Yes. If it is 2's complement, what is this number? Isn't it minus 1 only? Tell me. 2's complement meaning this is sign bit is copied from what? Copied from here, this original number. Actually original number is 1 only. 1 if you evaluate 2's complement, one important property we have, sign bit having what? Negative weight. All are sign bits only here. Original number might be this only. Correct? So this value is what? 0. So no overflow here. So what is this value now? Actually, you know, this is sign bit, right? It is copied from here. It is copied from here. It is copied from. This is the original sign. This weight is 1, 2, 4, 8, 16. Which is 16, sir? Minus 16, sir, this one. This is, sir, plus 15, sir. First plus 15, right? Plus 15. The result is what? Minus 1. Result is minus 1. I can represent it. So no overflow here. So this number is sir -1 sir. This number is sir -1 sir. So total is what, -2 I can represent, isn't it? So there is no overflow. Now this number is sir 65 sir. This number is sir 64 sir. So 129 sir. 129 can I represent in 2's complement range. Positive range is 127, negative range more is there, but positive range is small only. Therefore again, if I repeat this problem for this one is what, D only producing the overflow. I hope everyone it is clear. Everyone. Yes, ma. So these are the things, try to focus it. Let's move on to this one. So next topic, memory organization. Here majorly will focus on first initially memory hierarchy, followed by main memory. Very important things, ma. You all need to stay because we'll revise through expressions as well as some important gate questions have taken. Very old paper gate questions are we have. So then followed by cache memory will observe, cache memory. Then also we see the secondary memory also will observe here, secondary memory, secondary memory. Okay. First we need to discuss on memory hierarchy. What is this hierarchy which you will learn already? Okay, hierarchy. Hierarchy represents what? Arrangement of memories, right? Yes or no? We have to arrange the memories. We have to arrange the memories so that what is the essence of arranging the memories here? Essence of arranging the different memories into hierarchical form is to reduce average access time. So let's take topmost memory, we replacing cache memory. Central position of the hierarchy occupied by the main memory, please understand. Bottommost memory, secondary memories are, let's take disk is there now. So if I write levels, so levels, level 0, level 1 and level 2, we can write it. This is a memory hierarchy. Okay. So now topmost, this may be connected to processor CPU. In this CPU we have a set of registers will be there. Set of registers will be there now. Set of registers we have now. So this we know collect. Suppose what characteristic can I observe here? So when I move from top to bottom, when I move from top to bottom, sizes are increasing, isn't it? Time also increase, cost will reduce. When I go bottom to top, so what happens? Size will decrease, cost will increase, isn't it? Access time decreases. This observation. So in this topic, we need to know only thing is what? Finding the average access time. Finding the average access time in the 3-level memory hierarchy. Why different components are we are arranging into hierarchical form? To reduce average access time only. To reduce the average access time only. I hope things are clear. Okay. So now average access time of any memory system, suppose if you take any memory system, average access time of 3-level system if I want to calculate, how to do it? Suppose let's take this access time, let's take T1 I am taking, this access time let's take T2, this access time or let's take T3 like this if I take it. How to take the average access time of either 2-level system or 3-level system? That is this value completely depends on depends on the, so depends on this values are depends on how memories are connected to the processor. How memories are connected to the processor. One is what? Parallel connectivity. Parallel connection is there. Isn't it? Parallel connection. The second one case what? Level by level connection. There are 2 levels to level by level. There are 2 ways we can connect, level by level. So always to understand parallel connection is a faster one. Why sir? Parallelly all the memory components are connected to the CPU. So parallel buses will be there, So level by level nothing but what? Single bus system. We have a single bus. It has single bus system. It is a slower but economic, cost effective, correct or not? It is expensive, fast and expensive sir. Separate buses we have to keep for what? Each memory component. So based on this connectivity only average access time can be carried out, isn't it? All of you. So now case number 1 I am taking case number 1. If it is a parallel, please understand, tell me if I take 2-level system, 2-level memory system is given, So 2-level memory system. Let's take, I'm writing now. T1 is a level 1 access time. T2 is a level 2 access time. H1 is what? Iterate of L1. Iterate of L1. So H2 I am taking as iterate of L2 if I take it. So I hope you know these parameters. Yes, everyone responded. So do you know the T1, T2, T3, H1, H2 like this? What is the meaning of hit ratio? Can you tell me, all of you? What is the meaning of hit ratio? Hit ratio defines what? So number of hits, how many happen? Number of hits out of total number of references. Total number of references made by the processor. Total number of references made by the processor. That we call it. That we call it. So now with this respect, can you tell me what is average access time expression? Yes, all of you. Required response. What is average access time considering 2-level system with a parallel, all are connected. So if I want to see the diagrammatic view, this is a CPU, right? CPU is connected to level 1 memory system as well as what? Level 2 memory system, both are connected here. So I am taking this access time is T1 I am taking. So this access time is what? T2 I am taking. Iterate H1, this is what? Iterate is what? H2. Parallelly placed, correct or no? Parallelly placed. Address is parallelly placed. If it is it in level 1, please, if it is it in level 1, only T1 only required, isn't it? We can ignore this line. So both are trying searching parallelly, correct or not? If it is it in level 1, so this is stopped searching here. If miss occur, miss means we write 1 minus H1, then T2 is required. I hope this expression is clear, everyone. So now in the question, if it is not mentioned anything, by default is a parallel will be there. All of you should know, in a 2-level system, default expression this one. If parallel or level by level, if it is not given in the question, you have to take it this one only. I will tell you how to identify level by level connectivity, what kind of clues can be mentioned in the paper questions, so that can be observed. Amma, is it clear, all of you? Do you have any doubt on this one? Do you have any doubt on this one? Similarly, if I take 3-level memory system, 3-level memory system, can you please tell me how to write the average access time? T average access time. T average access time, how to write? How to write T average access time? So I have to search in level 1, if it is present, we can ignore other lines. If miss occur level 1, I need to test what? Level 2 also. You cannot guarantee level 2 compulsory hit will be there. So hit, if it has happened level 2. So if both the case miss occur, 1 minus H1 into 1 minus H2 what? So level 3 will continue. This is what 3-level system. Am I right, all of you? This expression is clear. Parallel connection cases, parallel connection cases. Yes, everyone? Yes, okay. So now case number 2 I am taking, case number 2. Level by level connection, very important this one, meaning CPU is connected to only level 1 system, level 1 memory, please, level 1 memory. So level 1 is connected to what? Level 2 memory, like this, level 2 memory, okay. Access time of level 1, let's take T1, access time of level 2 is, let's take T2. This hit ratio, if you take an H1, this hit ratio is what? H2. Can I tell always can I say one point? Iterate of L2 is what? Iterate of L2, level 2 is what? Can I say 100%? Iterate will be 100%. Can I say H2 equal to, by default H2 value can I write equal to 1, always 1. So in this case what happens? First we will search whether, like no, whether hit or miss will search here. If it is it, given to the processor. If miss occur, then we will go. We have to understand. Miss occur, then go to level 2 memory. These words are very important. When there is a miss in L1, search from L2. Miss in L1. So when miss word is given, you should understand that is a level by level connection now. Then from there you have to read and place it what here, like from there given to the processor. From there given to the processor now. Now suppose example, CPU generated 100 references assumption. CPU generated what? 100 references. How many references can be searched in level 1? Tell me. Tell me. How many references must search in level 1? Maybe it or miss, I am not bothering. How many references are searching in level 1? If CPU has given 100 references, isn't it all? All references we have to search in level 1 or not? Everyone? Yes ma, yes ma, respond, respond, respond. All references. Suppose example, I found 80%, 80 references found in L1 out of 100 means 100 I searched it, 100 I searched it, but out of which what 80 only I found it. This 80% is what? Iterate of what? L1, iterate of L1. Remaining 20%, please understand, remaining 20 we are searching from what? L2. So L2 we are searching, 20 we are searching from L2. So we already searched in L1, then additional required, this we call miss penalty also you can say. When there is a miss in L1, we are going to access data from the L2, that we call miss penalty. With this respect, how to write the T average access time? You understand now. When there is a it in L1, so it is there H1 into T1 I write. If miss occur, 1 minus H1 I am writing, right? If miss occur, I have to go to level 2, level 2 to level 1, level 1 to what? This one. So T2 plus T1 also can understand now. Actually there are 3 things are involved here. One is addressing, reading and transferring will be there, but transfer times are ignored here. Actually T1 is access time. Access time means, do you know what is the meaning of access time? Access time is not talking about transfer time. Access time nothing but amount of time required to be address the referred word and read it. First you address, read, then additional transfer time required. But the transfer time is based on the memory system, but that is ignorable because access time is taking more time only. That's what we are talking, access time only we are writing. This is expression. So if I simplify mathematically or directly also I can write, I am saying that whether it or miss in L1, always level 1 access time compulsory required or not? Can I write? Whether it or miss in L1, always you have to access what? L1 your T1 compulsory required. When there is a miss, additional time required. What is additional time? Level 2 required. Amma, if you mathematically simplify this one, you will be getting this expression only where M1 equal to what? 1 minus H1 only. Where M1 equal to M1 minus H1 also we can tell. This also I can say it time of L1, miss rate of L1, T2 can be tell, miss penalty of L1 also can tell now. As a verbal statement, what is the T2? Access time of L2, it latency of L2 or miss penalty of L1 also we can tell. Observe my words ma'am, because they play with these words. Miss penalty of what? L1. Level 1 miss occur, that is the penalty happen now. So sometimes they won't say level 2 access time. They will say, miss penalty of level 1 is what? 20 nanosecond. That is equivalent to access time of what? Level 2 only. So we have to be very careful with this one. Okay. This is clear now? So can I extend 3-level system this one? So suppose if I take 3-level memory system, 3-level memory system is there. Can I extend the formula? How to write it? T1 anyway compulsory required, isn't it? When there is a miss in L1, M1 miss run L1, I need what additionally what? T2 required, miss in. But always it is not compulsory, it will be in miss level 2, right? Then if both the case miss occur, sir, M1, M2, sir. So additionally what we require, sir? T3 required, sir. So this is very important expression you can understand now. Very important expression. for 3-level system. So 3-level system which you can observe it. CPU is connected to level 1 system, level 1 memory. So level 1 is connected to what? Level 2. Level 2. Level 2 is connected to what? Level 3. So level 3 connected like this. So access time of L1 is T1, access time of L2 is T2 assumption, access time of this one T3 is there now. When there is a miss here, I have to come read and given to this L1 to processor. When there is a miss, both the cases I have to read from year to year, isn't it? Now suppose I am saying that during execution 100 references given by the processor. Here is just let's take it is maybe 80 found out of 100. Maybe 80 found out of 100. Okay, now out of 100. Suppose here please understand in L2 please understand L2 happen, you know what I can say, 5 are its. 5 are its in L2. What is the it ratio? Can you tell me L2 it ratio? Can you please tell me in this pen? We call local it ratio also we can say. So in L2 5 reference are it, not all, only 5 are it. Local it ratio, can you tell me what is the local it ratio of L2? Also tell me global it ratio of L2. Can you answer my question, all of you? Those who are watching, very important. They may play very smartly in this terminologies. Tell me. I am saying the number in L2 level 2 only 5 its are there. It ratio of L2 very good. 5 out of what? 20. This we call local it ratio. Local it ratio we can. What is the global it ratio? I have to compare with what? This one. 5 out of what? 100. 5 out of 100 is a global it ratio. Is it clear? Is it clear all of you? Yes. So this expression can be even extended in terms of block transfers also when cache is maintained in the spatial locality. So just simply multiply any level you are accessing some data. The given time is what? 1 word. You multiply number of words are there. So expressions are same only. The spatial locality you can consider. Expression can be used it. Can you attempt this question, ma? Can you attempt please this question now? Just read this question. Tell me whether it is level by level or parallel connection. Read and tell me now. Every one of you. Yes, yes. You first you tell me whether it is connected level by level or parallel connection. Sir, level by level. Very good observation. How we understand, sir? 2 level cache system is there. 2 level, they are talking 2 cache systems are itself having 2 level. Access time of L1 and L2 given 1 and 8 clock cycles. They can also given in terms of clock cycles. So they are given what, miss penalty from a level 2 cache to the main memory is what? 18 clock cycle. Miss penalty. So this wording is enough to understand they are connected level by level. So miss rate of L1 is twice that of L2. Average memory access time already given, what 2 clock cycle is given now. This miss rate of L1, L2 they are asking. You might have solved also during your practice time this question, but this intention to take this question is that how to understand whether level by level parallel connection is given. So now is it nothing but 3 level memory system only now? So 3 level memory system average access time will be what? T1 plus what? Miss rate of T1 M1 into T2 plus if both the case miss occur. So both the case miss occur, we need to access what? Third level. So this expression directly can I use or not? Level 1 access time. Do not misunderstand. They may give in terms of clocks also. Calculate in terms of clocks only now. So miss rate. They said miss rate of 1 and miss rate of 2. Okay. There's some relation they given here. Relation given now. What is the relation? Miss rate of L1 cache is twice of that L2. Miss rate of L1 cache is twice of that L2. L1 miss rate is twice of that L2. So now suppose if I take L2 miss rate is X, so now L1 miss rate becomes what? 2X. Any doubt is there all of you? Do you have any doubt here? Correct? So therefore M1 is what? 2X into 8 clock cycle they told. So 2x into x into what? This is 18 clock cycle. They given the value 2 equal to 1 plus 16x, 16s plus 36x square. Okay. You find the x value, x you got 2x also get, then no doubt on this one, you will be getting the option A you will get it. So if once you got this one now, all question solving over, already over. Writing this is important. Till this step is important. Till this step is important. Yes, yes. Is it clear everyone? Shall we move for other things? Okay, move. So main memory. So memory hierarchy, that only just observe it. So look at level by level parallel connection, the expressions, observe it. Some questions you solve. In a main memory, please understand, okay. So this main memory broadly classified into 2 types now, please. Main memory also we can call primary memory also you can say. Primary memory also you can tell. This main memory or primary memory, okay. So this has a random access memory. Second class read only memory we have. Random access and read only memory we have, correct? Random access memory also we called read and write memory we can say. We perform 2 operations. We called out read only memory only we called. So read only memory only we called this one, read only memory now. This read write memory again further classified into one thing is what? Dynamic RAM. Dynamic RAM. Other is what? SRAM. SRAM. So this lot of versions are there. Only ROM is there. Programmable ROM. Erasable programmable ROM is there, isn't it? Like this a flash memory. Flash memory. These all are ROMs only. So now DRAMs are used in main memories. Please understand, all main memories nothing but DRAM chips only. Your all cache memories only what? SRAMs only. Please understand, there is no cache memory at all. We do not have separate cache memory. Cache memory is a synonym to what? SRAM only. Actually SRAM only. Basically it is SRAM. SRAM only, but we are calling in terms of conceptual view we are calling cache memory. Because it is maintain the locality of reference. Cache means what? It should be the moment processor asks something should be available immediately. That is the only point. So this is nothing but SRAMs only. DRAMs. So you might have studied configuration of the SRAM and DRAM configurations, memory expansions, two-dimensional representations, two-dimensional representation. Always any memory component if you take, so memory component you take any memory component if you take it, there are a few things are associated. One is address is associated, please understand, address, and data is associated, data lines. This is the data lines bidirectional, and control signals also associated, control signals. What are the control signals you should know? Read or write control signals, isn't it? Address, control signals and data. This is a main memory has things like this. Okay, now. So main memory size is defined, please understand, main memory size is defined like this, you know. So number of addresses, if I take n into size of the word m bit or something can be done, where n equal to number of bits required to address the memory. This I am talking about the main memory only. Number of bits required to address the memory. If you know, then number of locations, how many locations are there, I can get it like this. Number of locations I can get it with this one. And location size you multiply, main memory size can be, or you can multiply n into m bit also can tell now, where n is the number of locations or number of words in the memory multiply by word length, that gives the memory sizes. So I hope it is clear on like a byte addressable memory, word addressable memories, all of you. Two-dimensional configuration of the memory components, memory expansion, construction of the large memory size by smaller denominations. So did you study this all? Because this is a area where we can expect a question, 2 mark or 1 mark question may possible. So one question I have taken it from this one. So let's try it. Can you solve this one? A 32-bit wide main memory unit with a capacity of 1 GB built using 256 M by 4-bit DRAM chip. Number of rows in the DRAM chip is for 2 power 14 given. The time taken to perform one refresh operation is for 50 nanosecond. The refresh period is 2 millisecond given. Percentage of roundest to closest integer of the time available performing the memory read or write operation in this main memory is dash. So this question was asked in 2018 paper for 2 marks. Try it out all of you. Try and answer the comment and take a break for some 5 to 6 minutes, ma'am. So we continue it. Do not leave, because I planned for a discussion on properly on instruction pipelines as well as instruction format, encoding part, even bit of addressing mode and DMA controller. Those I am going to be discussed. Okay, so stay connected, ma. Try to work out this question. Take a break for 5-6 minutes. I'll come back. Yes, ma, all of you, how many people tried? So what is the answer? You might have no also answer, but important thing to be understand. What is saying that 32-bit wide main memory. This 32-bit wide says that one word size. One word they want to read it, what 32-bit they want to read it. 32-bit data they want to read it. Okay. Capacity of main memory is what is the main memory size they want to build it is 1 GB. 1 GB. The basic chip they given is what? What is the basic chip is given? 256 mega by 4 bit given now. This is a basic chip. Okay. Then rows and memory cells in the DRAM chip is 2 power 14 are there now here. So time taken to perform the refresh operation is 50 nanosecond given. Refresh period is 2 milliseconds before this you to do. Percentage time is available for performing the read and write operation they are asking. So DRAM chip is that is built with the capacitors. Binary informations are present in the charge form. So the capacitor is a leakage problem, means if it periodically if you are not refresh it or recharge it, the charges get discharged. The charge get discharged means what information you are losing. Therefore, every periodic time you have to be what? Recharge it. That is the nature of the capacitors. They said in a refreshing period is what? 2 milliseconds. 2 milliseconds given now. Another important thing, refreshing how we do it. So refreshing we do row wise. So 2-dimensional array form represented. Rows of like row by one row, second row, third row. Row by row you have to refresh it. Okay. But all the cells of the memory unit must be refreshed before this refreshing period. Otherwise information will lost. Another point. During refresh operation when we are performing, the memory unit will not respond for what? Read or write operation. It is busy because you are refreshing busy. It is not respond for what? Read or write operation. Means how we planned it, before reading or writing into memory, whether perform read or write operation, just before performing this operation, first refresh the memory unit. All the cells of the memory should refresh it. Once refreshing time is over, then you start read or writing. However, the amount of time taken to spend on refreshment is less only, consider less, very less value. Now, they given all the data, how much time, so during refresh time it won't respond. How much time is available for memory to respond for perform the read or write operation they are asking now. So let's see first configuration you see now. So memory size is what? Number of chips I must know. So number of chips, this also included memory expansion concept also included in this one. So 1 GB, so 1 GB by 256 M by 4 is given now. Can I write 1 GB nothing but byte nothing but 8 bits we can write, isn't it? By so 256 M only now, check it, 256 M by 4 bit, 256 M by 4 bit. So 2 times cancel. This we can write 2 power of 28, 2 power of 30, 2 power 28, 2 power of 30. Minus is what? 4. Isn't it? 4. Correct only, na? Just check it. Simply I am writing 2 power of 30 into 2 power of 3. I will write it. 2 power of 28 into 2 power of 2 I can write it. Is it? So this value is what? 2 power of 33 by 2 power of 30. So 2 power of 3 nothing but 8 chips we got. We got 8 chips, isn't it? What is the one chip configuration they said? The chip configuration if you seek, 256 mega into 4 bit is given now. This I can write 2 power of 8 into 2 power of 20 into what? 4. So this 4 is there. So this value 2 power of 28. So now see this is 2 power of 28, right? 2 power of 28 by 4. So now I am dividing like a 2 power of 14 into 2 power of 14 into 4 I can write. Meaning number of rows how many are there? So number of rows are 2 power of 14 rows are there in one chip 2 power of 14 rows are there. Clearly understand now. Now this column cells are 2 power 14 groups are made, each group size 8-bit 4-bit data, you have to read it. That's what they said also, no. It is not required to solve also, but they said clearly, no, we have each DRAM chip 2 power 14 rows are there. Rows are there now. How many such chips are, how many are there? How many chips you got? 8 chips. Now question is there, whenever you are expanding the memory from smaller to larger, or when you consider large memory by using smaller things, arrangement is very much important. Are we keeping all chips are vertical, all of them horizontal, some of them vertical, some of them horizontal? This arrangement of memory chips always depends on the amount of data I want to read it, word length only. So how much data we want to read it here? How much data we want to read it as per this question? So there is no 32-bit wide memory set, 32-bit they have to read it. One DRAM chip is able to read how much data? One DRAM chip able to read what? 4-bit data. 4-bit. I want to read it 32. Therefore, all this chip, please understand, all this 8 chips I should arrange into horizontal format only. Horizontal format only I have to keep it. So I am keeping this a chip, please. 1. This is a chip 2. So like this, you know. So last chip is here. Total how many chips we got, ma? Total chips we got, right? 1, this is 2, this is what? 8th one now. All 8 RAMs are kept here horizontal only. 8 RAMs are kept in horizontal only. The size is what? 256 M by 4. This size is what? 256 M by 4. This size is what? 256 M by 4. Please understand now. So we are expecting the data bus size is what? 32-bit we are expecting. Correct or not? This is the best way arrangement. This is the best arrangement you can tell now. Keeping all the memory chips in one row wise is horizontal is the best arrangement we can say. Why, sir? Refresh time is going to be reduced, sir. So here also arrangement how it happened? 2 power of 14 into 2 power of 14 into 4, isn't it? So 2 power of 14 into 2 power of 14 into 4, isn't it? These are rows and columns. So this size is what? One location size 4-bit, isn't it? 4-bit, here also 4-bit. With this some address please, if you identify this location, you should read consecutively all the locations like this 4-bit here. 4 into 8, 32, can I able to read it or not? Everyone tell me this arrangement is clear, as per the requirement arrangement is clear. I have to do like this only, so that I can read it 32-bit data, I can read it now. Now for this memory, how many bits required to address now? 256, but 28 bits required to address. Row selection is 14-bit, isn't it now? How many rows are there here? Can you tell me now? 0, 1, 2 like this, 2 power of 14 minus 1 is the rows. So the total rows are how many now? 2 power of 14 only now. How refreshing will happen? Refreshing will happen row wise. First all the cells in the row you complete it. Then go second row. Then go third row, like this you go now. Refresh time they given now. 1 row refresh time given. 1 row refresh time. Whatever 1 row refresh time is given now. 50 nanoseconds given now. So we are not refreshing chip by chip, please understand. We are all the chips are simultaneously refreshed, row by right. When I selected this chip is row 0, nothing but all row 0 selected here. So that every row of a chip is simultaneously refreshed. This is the best way of refreshing the things you can say now. So now total time for refresh operation. So refresh operation in a memory is equal to 2 power of 14 into what? 15 nanoseconds. Correct? Everyone tell me. The value is correct. Total time, this much amount of time you are spending on refresh only now. Imagine this all chips are vertical. So I have to multiply by 8, isn't it? We have to be very carefully, you have to observe the given data. Okay. Now during this amount of time, RAM chip will not respond for read and write it. What is the refresh period? Refresh period is what? 2 milliseconds. 2 millisecond, right? So now I am writing time. So amount of time is available. Time is available for performing, correct or not? Performing read or write operation. Read or write operation is equal to, I have to remove So period is what, 2 milliseconds minus, isn't it? This what you can say 2 power of 14, 2 power of what you can say 2 power of 14 into 50 nanoseconds. Or else what you can do, this only I can do it, correct or not? But they are asking percentage of the time is available for perform the read and write operation. So first of all I can do percentage of the time spent, okay, spent on refresh operation if I want to know. So refresh operation time is equal to, so 2 power of 14 into 50 nanoseconds, period is what, 2 milliseconds, is it not? Can we calculate this one? So this value is for 2 power of 14 into 50 nanoseconds, right, divided by 2 millisecond. 1 millisecond can I write a 2 power of minus 6 nanoseconds, can we write a required response from everyone? This value is. So can you please answer what is this value now? What is the answer? What is the into 100%, right? Percentage only required into 100%. Some of you calculate and tell me this value. Yes. Prabhava, Hamad. So what is the value it is giving now? Some of you give me the answer. Is it coming 40 point something? So approximately 41%, 40 point something, correct? So therefore now what is the question? Original question is asked. Percentage of the time available for performing the memory read or write operation in the main memory is equal to, so what you have to do, opposite value I should take it, correct? So this value if I take equation 1, so remaining time is available, right? So that answer must be 100% minus 1, equation 1. So this gives a 59%. Some of you given answer, Namana is given, right? Yes, Ahmad, 40.96 means 41%. So Namana is given right answer, 59%. So now answering questions okay, but configuration should understand how we did. This is very important point, like in the problem solving this question. Otherwise highly possible we'll do the mistakes. After getting 8 chips we understand, okay, 8 chips we got, 8 chips you have to refresh it. 8 chips you have to refresh, the right answer you will multiply 8 here. So that is the mistake can happen now. Okay. Next move on to the cache memory. So move on to the cache memory. So as we know cache memory things, okay, cache memory is what mainly used to maintain, it maintains what, locality of reference, isn't it? Locality of reference is maintains. So locality of reference itself we have what? One is temporal locality, isn't it? Temporal locality. One is temporal locality. The second one is the spatial locality we have. Spatial locality. Temporal locality, spatial locality. So temporal locality saying that, giving advantage like whenever any word is referred by the processor, it likely to be referred by the process near future, better you keep it into cache memory so that the future penalty can be reduced. So no need to go again and again into main memory to fetching same data. The referred word by the processor likely to be referred again by the processor in the near future. Keep it in cache. So spatial locality, spatial means what? Area. Some adjacent area of a program may likely to be referred by the processor near future. Better keep it what in cache memory so that future penalty reduces. So examples for temporal locality you can give for loops, isn't it? For loop, the instruction which you contain, same thing will repeat again and again, correct or not? Is a temporal locality. So when it comes to say spatial locality, array elements you understand, when array is accessed, when the first element, adjacent array elements also going to be accessed by the processor, we can understand now. Majorly cache memory design things you should know. One is what we have Address mapping schemes are important, right? Address mapping schemes you should know. Address mappings. Address mappings. The second one, block replacement algorithms required. Third one is so this cache having the coherence problems, cache coherence problems with data inconsistency problems it has. To resolve this inconsistent problem, proper updating technique I have to use it. Updating methods or techniques I have to use it. So these are the essential things you should be understand from the cache part. Let's quickly revise this addressing part. Addressing part quickly we will revise it. Just a minute, just a minute. Just wait for 1 minute. Just wait for 1 minute. Hey, students went. Yes, sorry for the interruption. Okay, just it got filled it. We reloaded the PPT here. Okay. So what I was trying to say here in this cases, I have to mainly discuss this address mapping schemes. So where address mapping schemes is required, please observe now. This is a memory hierarchy as we know. Okay, memory hierarchy. So this is a cache memory, right? Cache memory, please. And here is what main memory will be there, main memory. Then disk is there, secondary memory, disk we have, correct or not? Disk is there now. Listen carefully. So from disk to memory, data is moves in terms of pages we can say. Operating system side might have studied, say pages are segments we can call. Pages are segments we can call it. So now this is taken, this data transfer is taken care by operating system will take the responsibility for moving from disk to memory. From main memory to cache memory, data will move in terms of blocks. In terms of blocks will move. So moving data from main memory to cache memory taken care by cache controller. Cache controller we can say. Cache controller we can say. Please understand now. Okay. Now come to the point here. Okay. OS will take the responsibility from disk to memory in terms of pages or segment. This also we call logical address space. Please observe. So logical address space we are converting into what? Physical address space we are converting. Now physical address space we need to convert into what? Cache address space, cache address space, cache address space. Okay. So therefore we need address mapping schemes, please understand, address mappings to scheme to convert the physical address into what? To convert the physical address into what? Cache address. This is important point. Am I right all of you? So we have 3 address mapping techniques we have, correct or not? Very important area this one, very important area. Whatever doubts you have related to this one you ask all of you. Full associative or we can call full associative also we can call full associative address mapping scheme we can say. Third one is a set associative. Set associative address mapping scheme you can tell now. Compulsory you see 2025 gate compulsory question will be there in this area. The last year there was no question on there are 2 types of question can be seen on cache. One is time based question, other is memory based question, space based question can be asked. So last year there was no question on space based questions. We can expect a question from one of the mapping scheme can be seen. 2 mark question can be possible, highly possible 2 mark question on this 3 mapping methods are there. Briefly we will observe it. So briefly observe it each method. So you have to ask all the doubts related to this topic, all of you. Direct address mapping. Direct address mapping, please understand. It is a very simple address mapping, you can say. This is a simple method to implement. Why it is simple, sir? We record only one comparator, sir. Why it is simple, sir? It is record only one comparator, sir. It is using the function called k modulo n. The modulo function is using to mapping the main memory blocks into cache memory blocks. Isn't it, all of you? In order to perform this mapping method, first cache and main memory need to be arranged in terms of block wise only. So block wise you have to arrange it. So block wise you have to arrange it. Please understand. Cache memory, main memory you have to arrange it what block wise. Whatever sizes are there, whatever sizes is there, you have to arrange it block wise. Suppose let's take main memory sizes like 512 words are there. So cache memory size let me take as 64 words are there. Let me also take the block size is 16 words are there. 512 words by 16 words if I do, so we'll get 32 blocks, isn't it? So now blocks are there in a main memory like this, blocks are there main memory. Block number 0 to block number 31. So number of blocks I am representing M 32 here. Same block size 16, 64 by 16 if you do 4 blocks will come, 4 blocks will come, 4 blocks will come. So number of blocks in cache memory is what 4, isn't it? What is the function using? It is using k modulo n, where is n is the number of blocks, k is any block number. Take any block from number from main memory, apply this function, that result will give the block number in the cache, block number 0, block number 1, block number 2, block number 3, isn't it? This mapping mechanism also we call round robin fashion. 0 where will map it? 0 modulo 4 as per this example, 0 modulo 4. So 0 will map here, isn't it? 1 will map here, 2 will map here, 3 will map here, 4 will map here, 5 will map here, isn't it? 5 map here, 5 modulo 4 is 1. 6 will map here, 7 will map here, 8 will map here, 9 will map here, 10 will map here like. So 11, 12, 13, 14, 15 can map here like this. So round robin fashion allocation goes here. So one thing we have studied, like one thing you might have noticed that, so this one block can be referred by many main memory blocks here, right? For suppose if you take line number, line also we can call it, cache line also we can call this one, or block number or cache line also we can say. So out of 32, 8 are mapping, how sir? Like 32 by 4, so 8 will map to this location which are number 0, 4, 8, all divisible. So divisible of what you can say 4, 0, 4, 8, 12, 16 like this will map to this location. So confusion is that searching time. How to search important, because I can identify the block number, but in that block number we don't know which one is present. To solve this problem we are adding tag bits, correct or not? Every line contains a tag bits. Am I right or not, all of you tell me? So now tag bits are added here. Through help of the tag bits we can identify which block of main memory is present in the cache memory. Yes or no, all of you tell me? Then in this case searching, for searching, actually how searching happens, you know, CPU generates address, whatever address we generate with CPU we call logical address, or we can call effective address or virtual address, we can understand. So this address generally, you know, it will going to main memory. Actually, you know, one more thing, important thing I can tell you now, processor completely not aware of presence of cache memory. It is only thinking that I should get my data from main memory only. Wahnemann architecture, you recall it. Wahnemann architecture suggested that prior to program, any program you want executed, prior to this execution program you keep in main memory. So main memory address only given by the processor. The processor generated address to the reference to main memory. It is going to main memory actually. But I want to reduce average access time. That is the reason cache memory we added here. Cache memory we added to reduce average access time. Therefore, always address going to what? Here only like this. So you also might have noticed like no, this logical address is converted into what? The physical address, isn't it? Physical address, right? Physical address converted and going to main memory. So this is done by memory management unit. Operating system will take care translation, maybe through space table or maybe through segment table. This is picture of this picture comes from operating system point of view. This address going to what? Main memory now. So cache controller will capture this address, physical address, search into cache memory. So the physical address under direct address mapping, how many parts divided? Can you please tell me, all of you? This is 3 parts are tag bits followed by block offset number, we say block number, followed by word number within the block. So through which I can search into where cache memory, I can search into cache memory like this. Sir, if cache miss occurs, sir, simply take address and go memory, no problem. Sir, cache, I am searching some block number which is not present in the cache memory, take same physical address, visit the memory, identify the block, use a function called k modulo n, place it, that's it. When it is miss occur, if it is it occur in a cache memory, so you are searching from cache only, take the word given to the processor. This is the abstract view of what you can say cache role and main memory role and processor role here, and the way we do searching also on cache memory. So 3 parts are there, tag bits, block offset, word offset, isn't it? Can you please tell me this word offset bit or word number depends on dash? So this depends on dash, can you tell me now? Number of bits required to address the word number depends on dash, isn't it? Block size, important things now here. So block number, block offset, nothing good but giving a block number in the cache memory. This depends on the number of blocks in cache memory, ma'am. If I take n is the cache blocks, so I need how many bits required? As per this example, if I take, so main memory has 512 words, word addressable memory, 9-bit physical address required. So 9-bit physical address required. So now block size I have taken here 16 words. To address one word out of 16, 4 bits required, 4 bits. There are number of blocks are 4. So now 2 bits required to address them, 0001, 1011. Therefore I require 2 bits for this one. So remaining 2 plus 4, 6 means the remaining tag bits are 3. So like this can be calculated. This pattern is clear? So tell me, what is the limitation of this direct address mapping? This is simple, arrange into blocks, use a function, map it. Searching is divide the physical address 3 parts, take a block offset number, identify block number, compare tag bits. So whichever block is present, if it is it, so go inside the block through what? Word offset bit, fetch the word number given to the processor. If miss occur, take a physical address, go to memory, bring the block by applying function called k modulo n, place it one of the line, wherever line is given now. This is simple method, but its limitation is a majorly conflict penalty, isn't it? Sometime memory is cache memory is free, still it is creating a lot of miss rate. That is the biggest problem of what you can say direct address mapping. This can be resolved with a full associative. What the full associative says, tell me? Full associative says you take any block of main memory, place anywhere, no function, remove this function simply. No function is there. Am I right, all of you? In case of full associative, no modulo functions to map. You take any block, place anywhere. That we can say fastest mapping scheme also we can tell. Full freedom, full flexibility, no conflict penalties at all in case of full associative. Full associative does not have any conflict penalty. Why, sir? No conflict. Wherever memory space is filled, empty you can place it, that's it. But searching is difficult in case of full associative. Why, sir? You do not know where do you play, where you place, right? Searching is easy. I know where I place k modulo n. I can search only one block. That is the reason one comparator required in this case. In case of full associative, I have to observe entire cache memory. Therefore, if n blocks are there, n comparators require full associative. Am I right, all of you? In case of full associative, number of comparators required as per this example 4. 4 parallelly I have to compare it. 4 parallelly I have to compare it. So there is no block number. There is no block number, correct? There is no block number in full associative. There is no block number in full associative map. So in second mapping method, if I take in a second mapping method, physical address divided into how many parts? One is tag, other is what? Other is what? Word offset, that's it. There is no index bits here because index bits are helping to identify block number in the cache, right? I do not know where I placed it, then where is the index now? I have to search everybody. That's why tag bits are more here. Tag bits are more compared to what? Direct address mapping. Is it clear, all of you? But it is expensive, isn't it? It is expensive, sir. Why it is expensive, sir? Because more tag comparators required. To resolve this one, the combination of both direct and full associate is called what? Set association. Set associative, isn't it, all of you? Set associative. I hope you are aware of the set association. Set association combination of what? Combination of what? Direct and full associative. Combination of direct and full associative. Let's take a small example to get the clarity. Suppose cache memory has 8 block assumption, main memory has suppose 32 blocks are there here assumption now. So main memory has, let's take main memory has 32 blocks assumption now. Block number 0, block number 1, block number 2, like this 31 is there now. So cache memory has 8 block assumption 1, 2, 3, 4, 5, 6, 7, 8. Block number 0, block number 1, block number 2, block number 3, block number 4. So block number 5, block number 6, block number 7. N equal to total 8 blocks are there. Okay, it is a cache memory. Cache memory. Let's take I am using 4-way set association assumption. 4-way set association meaning. So now what is a set association? Defines. Set association defines blocks are grouped into sets. If I say 4-way set association, in one set 4 blocks are present, 1, 2, 3, 4 like this. Set number 0 I can say, this we can say set number 1. In one set 4 blocks. 2-way set association, in one set 2 blocks are there. K-way set association, in one set K blocks are present. Correct, all of you? The value is correct or not, everyone? So now number of sets, if I want to know number of sets equal to, so number of cache block by K-way set association. Number of cache blocks are how many? 8. So 8 by 4 equal to 2. We got 2 sets we got. It has a mapping function. K modulo not N, S is there, where S is the number of sets here. So number of sets how many? 2, sir. Suppose 10th block I want to place 10 modulo 2. What is the value? 0. Set number 0 you place anywhere. Freedom is there now, see. So 4 blocks are present now, see, freedom is there now. Suppose if I want to place it 15 modulo 2 is what? One set number 1 you can place anywhere, freedom is there now. When a set size increase, more flexibility. When set size increase, faster. When set size increase, expensive also more, correct or not? Too much set size increase, more expensive, correct or not? Set size decreases, less flexibility, less flexibility, more conflict problem can be seen, right? So we have a conflict problems here, but less compared to what direct mapping, more. So less compared to what direct mapping, more compared to what full associative. Its performance moderate, expensive also moderate compared to all three. So now when I divided it in a set wise, so now I need set number in order to search it, what we need set number, correct or not? Therefore physical address in this case is divided into how many parts, ma? Tag bits are common to identify it, set number followed by word offset. Word offset not going to be changes. Additionally we have a set number. First to identify set number, within the set number parallel you search all the cache blocks, wherever it is present you can identify it. Now my question to you, as per this example, how many comparators required? Can you please tell me? As per this example, how many comparators required? Everyone. As per this example, how many comparators should be there? Answer it. Because K modulo S gives set number 0. But set number 0, I don't know where you place, right? Every line having cache bits only. Every line having cache bits, tag bits we have, right? Tag bits we have, right? Tag bits are there, tag bits are there, right? Tag bits are there now. Searching time, I am searching set number, either one of the set I will search it. One of the set I will search it, isn't it? One of the set I search it. In that set, after searching, how I know where my block is present here or here or here? So that I have to parallelly compare. Therefore, number of comparators required how many? 4. 4 comparators required, Prabhava. How to generalize K-way set association having how many comparators now? In a generic form, if I want to say K-way set association have how many comparators? K comparators. K defines the number of blocks in one set, because we do not know in that set where it is present, right? K-way set association required, K comparators required, compare parallelly. So that you have to understand. Is it clear, everyone? It is clear. Now, lot of questions framed, just try to divide this into 3 patterns. Many times asked word of set value, set of set value, what tag bits. Under 3 approaches they asked it. Under 3 approaches asked it. So final comparison, if I want to see first and second and third method, okay. One is a direct and a full associative set association. If I use K-way set association, K-way set association. Comparators, how many required here? Can you tell me now? Comparators. Here is 1. Here is what? N blocks are there. Here is what K required now. Getting my point? So now cost of implementation, please understand, cost of implementation, it is low because of what? Less comparator. It is very high because of comparator. This comes under moderate. Okay, moderate. The physical address divided into what? Tag plus block offset plus what? Word offset. Here is what? Only tag bits plus word offset. No index bits here. Here is what? Tag bits plus set offset plus word offset. Word offset. Is it not? Like this, some information can be understand now. Conflict problems, if I want to see conflict problems, conflicts. Here are more conflict. Here is 0 conflict, no conflict. Here is what? Less conflict, you understand now. Full associated, no conflict problems are there. No conflict, because you can place anywhere. So conflict, you know, right? Though having the empty space, but still miss is happening now. The block which I want to search it, that got replaced by another block, though having the empty space, is conflict. 2 or more blocks are conflict in same, though having what? Memory space. If do not have memory space conflict, going to same set, same block means, okay, we can understand due to capacity means one is removed and other is placed. Having memory and removal happen means what? That we called conflict. Under full associative, we do not have a conflict. Can you try this question, all of you? Okay. In K-way set associative cache, the cache is divided into total V sets are there. So each of which consists of K lines. One set as K lines are there. K-way set association. The lines of sets are placed in sequence one after another sets. Line in a set S are sequenced before line in S plus 1, one by one. Main memory blocks are numbered from 0 onwards. Main memory block number J is there, that has to map to any one of the cache line from dash to dash, they are asked it. Okay. This is a very nice question, I can tell. Very conceptual question this one is. Very conceptual question, this one. Can you please answer, all of you? What is answer? I will be giving 3 minutes time, I will give it. Try this one. 3 minutes I will give it. Try this question, all of you. Yes, yes, try yourself. Yes, anybody tried? So first line is J modulo V. First line is J modulo V. So you're saying that C and D can be directly eliminatable. C and D are directly eliminatable, right? So what about B? B also having J modulo V. So one thing we should notice here, ma. Suppose if you know this block range, suppose example I am taking one example I am taking before answering this question. Suppose block number is there, okay. Block number and word range in the blocks I want to know. Word range in the block I am taking, in the block. Let I am taking okay, main memory has 32 blocks assumption. How many blocks are there? 32. So one block size I am taking, one block size. Let's take 16 words are there. How the range can be seen, we'll observe it. So that little clarity will come to solve that question. Block number 0 as can I say 0 to 15 words are there? Any doubt is there, all of you? Please respond. Please respond. Any doubt is there? 0 to 15 words will be the block number 0. So block number 1, when 32 blocks are there, where I arrange data like this. Block number when start from 16 to what? 31. Any doubt is there? So at block number 2 has what? 32 onwards to what? 47. So block number 3 is having what? 48 to 63. Like this we can write, correct? Suppose if I ask you 10th block having the word range, can you tell me now? 10th block has a word range from where to where? So to answer this one, what you can take? Take same 10th as it is, 10 block number, take block number. Multiply its block size. Let's take, I am taking block size P words are there, P, just P words. So multiplying P, starting will come. So this is starting address will come. Again, so 10 into P, add it to P minus 1, you add it. This will give the range of the words you can tell. Example, I am generalizing this one even. K is a block number I am taking K into P equal to, so K into P plus P minus 1 is the range of the word I am writing. You can check this option, block number 0. 0 into P 0, 2, 0 into P 0 minus P minus 1, P minus 1 is what? P is what? Block size 15, isn't it? Suppose if you take block number 2 has a ranges, 2 into P, P is having what? P indication 16 words. So 2 into 16 is 32, 32 plus 15, 47. Will it make sense, my everyone? Prabhava, Naman, Namana, Hamad. Can I see word range in that? Any block can I ask? Now you can answer like 31th block range also. Can you able to answer it? 31th block range, what the word numbers are there? Can we answer like this? Yes or no? Yes. Now similarly, suppose I am taking set number, one set as suppose, so let's take a K-way set association. I am taking set number. I want to see set range in terms of blocks. I want to know like this. Now set size also I am taking set size. Let's take K-way set association. K equal, let me take 4 assumption. K-way set association, K equal to 4 I am taking now. Now can I answer set number 0 has the blocks 0, 2, 3. Can I write out like this? Set as K-way set association. K nothing but I am taking 4. 4 blocks are there in one set assumption now. So set number 1 has one from what? 4 to what? 7, isn't it? Set number 2 has what? Tell me now. 8 to what? 11, correct? Now suppose one this giving something like, let's take some set number. Let's take I am numbering as P set number, P assumption now. P set number as P into size. What is size? K. 2. Can I write it now? P into K plus K minus 1. Can I write this will give set number? Hello. Correct? This is set number giving. Set number as this from year to year. Correct or not now? Generally we studied a mapping function. Correct or not? Generally we studied mapping function of year. K modulo S. What is K modulo S gives? Tell me. K modulo S gives a set number, isn't it? K modulo S gives a set number. K is what? Main memory block number. S is what? Number of sets. S is what? Number of sets. So now come to the question now. They said there are V sets are there. V sets are there and we have to map what? J is what? Any particular block number. Now set number, how to get it? Set number, can I get it like this? In place of P, can I say, so J modulo V giving what? Set number or not? Respond everyone. J modulo V, J is a block number of main memory block number, mapping to number of sets, nothing but set number will give. So can I, wherever P is, can I replace for J modulo V now here? So J modulo V, isn't it? The rest is same. So J modulo V gives set number, set size I have to multiply starting set number if I want to see. So now come to the options now. Some options directly eliminated. J modulo K cannot be, J modulo K cannot be like this. So J modulo V giving set number, when I want to know set size, I should multiply set size also. K is not present and that too minus, okay, this is okay, but K is not multiplied. So therefore I can say option is the right answer. To solve such questions, you should aware of this one. This is a basic idea. The basic things, if you know, automatical ideas comes, okay, what they want to test it. I am telling what is the challenge, if you understood question, 1% only solving, now solving time takes what? 1% only. Generally we spend time to understand only. 100% you should understand. 100% you understood nothing, but you will find your own logic to solve that question. You will find your own logic. You will find your own logic to implement that one. I hope this is clear, everyone. This notes will be PDF, will be shared it. This will be shared. So as I mentioned, try all of you to register the zero fee program in IMS. So the link is provided in the description and registered. You can watch the free sessions of the remaining all revision sessions for other subjects also. That will conducted our own platform. No need to pay any money. The free of cost other subjects are going to be revised such a way only, like computer networks, DBMS, algorithm. Upcoming week we planned it. Full revision on this subject we planned it. So that is going to be help you as well as enrolled students, even other students also. Okay. Another interesting questions I would like to take up. This was asked in GATE 2022 paper. Now see. A consider system with a 2 KB direct mapped cache with a block size is 64 bytes given. System has a physical address space of 64 KB and word length 16-bit given now. During execution of program, 4 data words are given P, Q, R, S. Word numbers, there are word numbers. You have to read clear, word numbers they said are accessed in that order 10 times accessed. PQRS followed PQRS, PQRS like this. 10 times means total 40 times. Hence there are 40 access to data cache together. Assume that data cache initially empty, cache is empty, and no other data words are accessed by the program except other than these are data words, no other data accessed by the program. The addresses of the first bytes given P, Q, R, S are they given like this. So like now you can see 1, 2, 3, 4 hexadecimal, 4 into 4 16 address, physical address 16 bit also can understand now. 4 the bytes given like this respectively. For the execution of the above program, which of the following statement is or true with respect to the data cache? With respect to data cache they are asking. So now options given, every access to word number S is it. Once P is brought into the cache memory, it is never evicted. At the end of the execution of the sequence, only R and S are reside in the cache memory, they are saying that. Every access to R evict, so every access to R, it evict in the queue from the cache. Like this options are given. Let's try it together. So by that time what you can take this question screenshot, you can read it also simultaneously. Take the screenshot of it so that immediately we can solve it. Okay, and I'll show the options also. So parallel both of us solve. Yes, noted. Noted the question. Very interesting question, ma. It is not again not tough, little lengthy. Such questions you have to solve second cycle. First cycle should not solve. Okay. Take these options also. Take the options also. Done. Okay. So let's take the given data. Given data. Consider cache is 2 KB direct mapped cache given. Cache size I am writing. Cache memory size 2 kilobytes given now, and block size given as 64 bytes given now. 64 bytes, isn't it? 64 bytes given. Physical address space is 64 KB given. Physical address space nothing but what? Main memory. Don't get confused. 64 KB given now. 64 KB means we can write 2 power 16 bytes I can write it, through which a physical address getting 16 bits is a physical address. So no doubt of this one. Suppose they given here 1 point. So word length is 16 bit given. Sir, is it word addressable or byte addressable? May get a doubt. So looking at these words, see now words they mention. Okay, data words P, Q, R, S are accessed in that order. Now see how many digits are there? 1, 2, 3, 4. So hexadecimal 4 into 4 16. The 16 bit address only. Physical address is what? 16 bit only. No doubt on this one. Physical address 16 bit, which we got. Now I must know under direct address mapping how many blocks, what is the block offset, those things we need to find out. So let me take, so number of blocks I want to find out. So number of blocks in cache memory, how to get number of blocks n I am representing, that is nothing but cache memory by block size I can do. Cache memory is what? 2 KB, block size is 64 bytes. So this we can write 2 power 11 bytes by 2 power 6 bytes I can write it. This is 2 power 5, nothing but 32 blocks will be there, isn't it? 32 blocks. As we know, physical address under a direct mapping 16-bit is divided into how many parts? Tag. So one thing we have tag, block number and word offset. Word offset depends on the block size. Block size 64, nothing but 6 bits required. Block offset depends on the number of blocks. Number of blocks 32, nothing but 5 bits required, isn't it? So this this should be also 5. This is a distribution 5 5 6. Correct? This is a distribution we got. Now, so mapping we have to do this one actually, no, based on the answers, no, every access to S is it. It means initially cache is empty, nothing but they are coming into cache memory, correct or not? I should know where they mapped it, which line number they mapped it, we should know. How many blocks are there? Number of blocks, how many we got? 32 blocks are there. 32 blocks are there. Let's observe now. So now let me take PQRS words also. PQRS word numbers. So I am taking now PQRS word number. PQRS. Okay. So P value given as what is the P? A248. A248. Q has given C28A. C28A. R has given as third one. PQR. CA8A. CA8A. S has given as A262. A262. Let's write a binary and divide it. A, how to write this one? 1010, right? 2 means what? 0010. 0100, isn't it? 81000, right? This I can write 1100. 0010, 1000, 1010, isn't it? Now this I can write 1100, 1010, 1000, 1010. This I can write 1010, 0010. 6 means 0, 0, 1, sorry, 0, 110. 2 is nothing but what? What is the 2? So 0010 I can write it. So these are the, what you can say, binary pattern of this one, right? So under direct address mapping, just a minute now. Little gap I want to give it. So tag bits are 5, word offset what 6, right? 4 plus 2. I am dividing like this here. 1, 2, 3, 4, 5. Here is division. Can you see? Again 4, 5, 6. 1, 2, 3, 4, 5. So rest is 5 we have. This is 6, correct or not? 1, 2, 3, 4, 5 like this. So 1, 2, 3, this is sixth one. 1, 2, 3, 4, 5. This is a division happen now. So this is giving block number how much more? 9 it is given, right? 9 block number is giving now. Block number 9 is giving. This value is giving 10, block number 10. This value also given 0, 1, 0, 1, 0, 10 only. This giving what? 9th block giving. But tag bits, you see that these are tag bits are 1, 0, 1, 0, 1, 0. These tag bits are same, isn't it? P and S are having same tag bits. P and S are having same tag bits. These are different tag bits. Direct address mapping, we searched it. Block number 9 and 10 only, most of them are there. So let me draw this little map. Here is, okay. So block number 0, block number 1, block number 2, like this, you know, there is some block number 0, 1, 2, 9, 10 is there, like this 11, like this. Last one is what? Total blocks, how many we got? 32 means 31, 31, n equal to 32, correct? Initially cache is what? Empty. What is access? P, Q, R, S. P, Q, R, S. P, Q, R, S. Will go like this, correct or not? Let's first one is P. First time P is hit or miss, tell me now. P is what? Miss only. Dot I am referring, P is miss. Word number P is present here. Word number is not a block. One of the word block containing what? Block containing 32 bytes are there. So 64 bytes are there. One of the byte to understand, one of the byte we are looking. That is miss. So miss dot is there. Then that block number, this comes under which block number? We know which comes under block number 9. So 9 modulo 32, where it will go? 9 modulo 32. What is the mapping function we are using? We have to use mapping function is what? K modulo n only na? K modulo what? 32. So 9 modulo 32 is what? 9 only. In 9th block P will come. 9th block P will come. So its tag bits are updated here. Tag bits are updated now. Correct. Q also miss only. Q also miss only, right? Q also miss. Where Q is mapping now? Where Q is mapping? Q is mapping to 10, right? Q is mapping to 10. So now Q came here. Q came here. So this also miss. R. Where R is mapping? Where R is mapping ma? So Q is mapping 10 only. Where R is mapping? 10 only. So 10, are the tag bits are same? Are the tag bits are same? Amma, if the tag bits are same, those words are belong to same block, correct? Yes or no? If the tag bits are same, nothing but same block only you are referring. Same main memory block you are referring, correct or not? It is saying that 1, 2, 4, 8, 16, 24th block number, 25th block number. Main memory block number 24th, 25th as per the data, which are not same, correct or not? What happens now? So when R comes, what should I do? It is also mapping to what? 10th only. You have to remove this what? Q you have to remove, place it what? R you have to place, R placed it. Yes. So yes also miss, correct? Yes, miss or it you tell me. Yes. What the S is telling now? What is the S? Yes, you are searching for 9th block. So 9th block do have, in a 9th block do have anything? In a 9th block do have anything? Yes, we have P. Whether that block is present to me, belongs to me or not, how should I check it now? Tag bits have to verify. Yes, tag bits 1000, 1000. Therefore, yes is it or not? Tell me now. All of you tell me. Yes is it or not? Yes is it or not? Tell me now. S will be it only. Okay. Next P. P is it or not? Tell me now. P. Repeatedly same thing you are accessing, correct? P is it or not? Tell me everyone. Value of P is it or not? The word number P is present. So now I am telling S also present, P also present here only, isn't it? So P also it. Q is it or not? Tell me Q. Does Q is it? Required response. Hamad, Namana. Q is what? Miss. Q is miss. So I have to remove R, place it what? Q now. Then R is what? Again miss. Remove Q, place it R. S is will be it only. P will be it only, correct or not? So now last will be what? P, Q, R, S will be there, right? P, Q, R, S will be there now. So in this moment last is it. P, Q, P is it only, right? P is it. Q will be miss. R will be missed. S will be it, correct or not? Finally, at end of this execution, what are the words are present in the cache memory? Can you please tell me? Comment it. What are the word numbers are present end of this execution? So now Q is it nothing but R might be replaced by Q. Q is replaced by R, isn't it? So S will be it, P is it. Isn't it P S R will be there? Hello? P comma S comma R will be there, end of this execution. S cannot be miss. S cannot be miss, please. S is part of the P only. Their two words are referring into same block. They are part of the same block. Yes, very good. Now you select the options. Select the options. Now see, once you observe the data, answering question becomes easy. Now tell me what are the options are right. Every access to S is it or not? 100% right. Whatever time you access S is, it was part of the P only. Once a P is brought into catch, it is never evicted, never removed. This also true. Correct? Respond. Respond. At the end of the execution, only RS is reside in the cache memory. Absolutely wrong. Every access to R evict the Q. This is true. Therefore, A comma B and D are correct. Don't decide immediately. Before only there is MSQ question. MSQ question should decide based on your answers only. It is basically I am telling MSQ question. MSQ question. Okay. The question is good or not? See how nicely they framed this question. Correct? Every one of you. Chalo, we'll move for another question. Other interesting theoretical question they are framing, this one. So read properly, you know this cache updating methods we have. Cache updating methods we have. One is write through protocol, write back protocol. So write through nothing but simultaneous updation into cache and main memory. Write back nothing but only you do updation for main cache memory, and final updation goes to main memory when memory execution, program execution over, or any concerned cache block chosen for removal. Implementation of write back will be based on what? Dirty bit only, correct or not? Read and answer it. I'll be giving a timer to you. Don't guess it. Please don't guess it, all of you. Do not, this is required time. Understand yourself and tell me the answer. So which of the following statement is or true only they are asking? True statement only they are asking. Work out. Yes, yes. Work out all of you. Everyone, option D is visible or not? A right miss. A right miss in WTC, always write the victim cache block to main memory before loading the missed block to the cache. Yes. What are the statements are right? Sir, a false because never is not always. B is true, C is true. Namana C is true, saying that A, B, D. Consider two set associative cache memory, two-way set of architecture given. WC which uses the write back policy and WTC which uses a write through policy. Both of them use the LR, least recently used algorithm. The cache memory is connected to the main memory, level by level connection also mentioned. So which of the following statement is are true? Okay, you are saying that option D is not visible because of some pattern is some sticker is coming, correct or not? I'll read also. A write miss in, let me go with one by one. True statement asking. A read miss in write back cache. Write back cache is there, means what? Whenever, what you can say, we have to write back to main memory whenever block is chosen for removal, that's it, we know. A read miss occur in cache memory in case of write back, never evict the dirty block. Suppose I am reading in cache memory, miss occur, I went to main memory, I read the data, block I brought, I want to place it cache memory. I want to place it cache memory, cache is full. Then you have to remove block, correct or not? Remove block or not? That selected block, please. This selected block can be dirty, isn't it? Selected block can be dirty or not? So we cannot say never. Therefore, option A is false. Yes, selected block can be dirty. A read miss in write through never triggers a write back operation of the cache block to main memory. So WTC nothing but write through protocol. In case of write through, it read, I am trying to read in cache memory, it's not present. Therefore, I can go and read into from main memory. When I read it, you understand, I brought into main memory, cache is full assumption now. Simply I can delete the block. Can I simply delete the block and place it or not? Why, sir? Whichever you update in cache memory already simultaneous updated in main memory. There is no any dirty reads, dirty data in a cache memory. Therefore, a read miss in write through never triggers a write back operation of a cache block to main memory. This is 100% true. Statement B is true, A is false. So A is false. A write hit in a write back C can modify the value of the dirty bit of a cache block. Suppose I am trying to write in cache memory, writing updating cache memory. If it is it, you modify data, you write and write. You modify data, you are written already. Should I update the dirty bit or not? If you are not updating the dirty bit, nothing but it is very problematic. So dirty bit is itself meaning that small, if one word of the block is updated, it changes some initial value. So make it dirty bit equal to 1. So this also true. So write it in a write back cache can modify the value of the dirty bit of the cache block. Is it? True. Next, a write miss, I repeat my statement, a write miss in WTC, write through protocol, always write the victim cache block into main memory before loading the missed block in the cache memory. Before loading the missed class memory, meaning suppose I want to write it something into cache memory under write through protocol. Under write through protocol, I want to what is saying? I want to write in cache memory. Miss occur. I went to main memory. I brought a block. I am placing it in cache memory. He is saying that when you are placing the block into cache memory, always missed block you should write back into memory, then load it a new one. He is saying that. Is it true always? When write miss occur in write through protocol, write the victim which is missed occur into main memory before loading the what? Missed block into cache memory. Is it true always? Tell me option D is correct or not? All of you. Option D is correct? Option D is correct? Every one of you. Every one of you, please tell. Does option D is correct? Option C is right only? Option D? No, sir. No. Option D is incorrect, please. In case of write through, it is not necessary to write back it, not at all, not necessary, not necessary. Therefore, correct answers are B and C. Correct answers are B and C, ma. Yes. So like this, you try to focus on this methods, ma. Good number of problems, try to solve it, so that it will be easy to answer the questions, ma. So next we will move for secondary memory. Secondary memory majorly try to focus on magnetic disk. So magnetic disk part, in which you should aware of finding the capacity of a disk. Capacity of disk. Capacity of a disk you should calculate. How to calculate? Number of tracks per surface, number of tracks per surface, number of sector per track, and sector size B I am taking. So now unit is bytes I am writing. This you should know. Where T refers what? T refers T equal to number of tracks. Number of tracks for surface. Surface. Where S refers number of sectors per one track. Where B refers size of sector. Size of sector. This is important thing, should notice. Yes, Ahmad, is always wrong. That is wrong only. It's not always true, I should tell. It is always wrong only. This one thing you should know. And other thing, please understand. T average access time of a disk. T average access time of a disk. T average access time disk refers to the amount of time required to read a sector from the disk. So that involves majorly three components. One is seek time plus average rotational latency. Rotational latency nothing but half of the one rotation plus data transfer time, and otherwise controller overhead also. Disk controller overhead also we can say. Controller overhead. So this is optional value. If they given you take, otherwise ignore it, this one. Okay. Seek time, you know definition of the seek time. First, like suppose this is there, like we have n number of tracks, n number of tracks are there like this. Particular data I want to read it, suppose you understand. First I have to go to this one, correct or not? Particular track I have to go, that is a seek time. After that header cannot go, you have to rotate this one platter to keep it under this read write header. That's what sometimes one rotation, zero rotation, half rotation required. That's why we have taken a half rotation. Then start reading the data transfer time required. This is the expression for what? Average access time for a sector. If not mention sector also, if I say simply find the average access time of a disk, nothing but what? It is only talking about how much amount of time required to read a sector from the disk, that we call average access time. So one more third point you should understand, sometimes they will put it, some file is a very big file is there that we store in terms of sectors. These sectors are randomly thrown. Sectors are what? Randomly thrown given. When randomly thrown is given, such cases what you can do, the total time equal to simply, so number of sectors into T average access time you should know. Why? Because for each sector access requires seek time, rotation latency as well as transfer time required. When randomly distributed, this you should know. Okay. Fourth point, you should also know data transfer rate. Should also know what? Data transfer rate. Data transfer rate is nothing but amount of data transferred by the disk or rate of transmission. This also we called bandwidth, also we can call. Bandwidth also we can tell. Bandwidth of the disk, throughput of the disk also we can say. This simply we can calculate one track capacity. So one track capacity by one rotation time you could multiply, divide it, one rotation latency. So this units are bytes per second will come. Unit will come what? Bytes per second. Am I right, all of you? Hamad, Namana, yes. Required response. So DTR, average access time, and the capacity of the disk is important. Now in order to increase the data transmission rate, we are arranging the data in terms of what? cylinder wise, correct or not? Cylinder wise. What is the cylinder talks? Cylinder talks what? Are like no, what you can say, cylinders are nothing but what? So like corresponding, okay, what you can say, similar tracks across the so surfaces, you can see like this, you know. So this is a track 0, suppose you take this is a track 0, right? Like this, you know, take track, this is a similar portion tracks, cylinder number 2, cylinder number 3, like this, you know. Cylinder number 0, cylinder number 1, cylinder number 2, like this. Cylinder wise we store it. When you store cylinder wise, transmission rate can be more like this. Now the cylindric having the two types of address we have, correct? One is logical address, isn't it? Logical address. So logical address represented by what? Cylinder number, surface number, what? One is sector number, isn't it? And second one have what? Linear address also we have. So linear address, what is the linear address defines? See, linear address nothing but everything you have to express in terms of sectors. Let's say one cylinder size, how much? Suppose example I am making into like a 4 sectors are the assumption now. One surface has 4 sectors. So I should know cylinder has how many surfaces, let's take m into number of sectors per surface plus surface number into number of sector per surface plus s. So this is the expression you can understand now. Where m is what? M is number of surfaces. N is what? Number of sectors per surface. H is what? Surface number. S is what? Sector number. Sector number. So I hope this is clear. Example, if you take the surface number 0, surface number 1, surface number 2. 0 cylinder, if you take cylinder 0 has 4 surfaces, each surface having 4 sectors, right? 16 sectors we have like this, no? See, 4 plus 4, 4 plus 4. Sorry, 8, 8 plus 8, 16, correct, 16 we have now. This is very important, logical and linear address, very much important, okay. You know, right, addresses, if this given you can calculate like this. If you know this linear address, how to get a logical address, ma? I know linear address of x sector, then what should I do? I have to divide by what? My cylinder size in terms of sectors, m into n, divide, you will get cylinder number you will get, correct or not? Whatever remainder R1 get, that remainder R1 you should divide by n, divide by n. You will get what? Surface number will get, surface number will get. This final remainder whatever you got, that is going to be sector number, sector number. Linear address is there, triplet address can be found it like this. I hope it is clear. So these are the things to be revised more clearly, okay. So one question I would like to take here, can you please answer now? So this was asked GATE 2013 paper, yes, 2013 paper asked for 2 marks ma. Try, you know the basic on this information only, try ma, I am giving 3 minutes time, try this question. Try this question ma, all of you. Yes, anybody got the answer? Yes, yes. 16 384 cylinders, nothing but this many tracks are there. Each cylinder contains 64 sectors per surface. Data storage capacity of sector is 512 bytes. Data is organized cylinder wise only. Addressing format cylinder number, surface number, sector number, logical address given. File size, this much of file size given now. Is stored in disk. Starting address is given like this from year to year. What is the cylinder number of the last sector of the file if it is stored in contiguous manner? Last cylinder number ask. Solve it. So meaning starting address is this one, right? Starting cylinder number this one, something value is there. From this onwards file is stored it. So now after storing sector form only stored, right? What is the cylinder number that last sector containing, they are asking. So what is the cylinder number of the last sector of that file? So starting address given. What is starting address? 1200 sector number, cylinder number 9, 40. 9, 40, isn't it? 9, 40. Now total how many surfaces are there? 64 surfaces, 64 sectors are there. What is the file size? File size is 42797 KB. 42797 KB file size is there now. This is the file size we have, right? Now simply they are asking cylinder number only. Can we answer like this? How many cylinders required to occupy this file? How many cylinders required to occupy this file? How to calculate the cylinder size? How to calculate the cylinder size? Number of surfaces into, in each surface how many sectors are there? Multiply by sector size, isn't it? So I can calculate one cylinder size. So cylinder size can be calculated. So number of surfaces into number of sectors per that one into and sector size I can do it. So this is diagram, no? You see this cylinder 0, I want to know how many sectors are there. 4 plus 4 8, 4 plus 4 8, 16 sectors are there. If you know 16 sector size, we will get a cylinder size, right? So cylinder size I can get it. So as per this example, number of surfaces, how many? 16 surfaces are there. 16 surfaces. Number of sectors, number of sectors are 64 also there, 64. What is sector size? Sector size 512 bytes is there, 512 bytes is there, 512 bytes is there. This is your cylinder size. Now starting cylinder number how much? 1200. This 1200 cylinder not filled it because this has to come 64, it has to reach to 64, 63, 63 reached. It is not filled. The cylinder number 1200 is not at all filled it. Now onwards if you start cylindering, how many, what is the last cylinder number I can get it. So what I will do it, number of cylinders required equal to, I will write it, So number of cylinders required to store this file is, what is the file size? 4279. 42797 KB, 1 KB nothing but what? 1024 bytes, isn't it? So divided by 16 into 16, 16 into 16 into 16 into 16 into 512. So 512 bytes. So byte cancel, this 2 times cancel, correct or not? So this cancel 8 times. Now 42797 by 16 into 8, somebody give me this answer. Somebody give me this, what is this value? Exact value tell me now. 42797 by 16 into 8. 1241? No, I don't think 1241. Is it 1241? May comes. anything we missed it? We have taken number of surfaces, how many? Number of surface 64. So, number of surface 16 into 6, sorry, we did wrong I think. This value 64 ma, please, 64 surfaces are there. So, this value just I am changing here, 16 into 64 into 512 bytes. Anyway, 2 times we got this, nothing but 8 by 8 into 64 ma. What is this value? No, some wrong was there, my calculation wrong. Now you can tell me. Now you can tell me. What is this value? Yes. Required response. Because quickly respond, we have to see some more topics also. Main thing is we have instruction pipeline, addressing modes, instruction format we'll see, we'll cover it. 83 point something, nothing but definitely 84 cylinders required or not. You cannot tell 83 point something or 84 cylinders required or not to cover this entire file. Hello, am I right or not? Now starting cylinder number is what? 1200 comma 9 comma 40, is it not? 40, right? Now 83 point something, 84, some value will be there. Now 1200 starting plus what? 84. So 1284 is a starting cylinder number, maybe some values will be there, I am not worrying this one. So this is your answer, is it not? Okay, very no problem. So now 1284 is the right answer. This way you can do it. Is the simplest way to solve. Sir, other way how to solve, sir, how to understand, other way also can be solved, other way I am giving, you can try. Yes, you are right, 1284 is correct. Other way what you can try, you get the linear address, fully linear address. Find the number of sectors required for this one, add it. Number of sectors, add it. Last sector's linear address will get, that divide by again cylinder size. Cylinder number, surface number, sector number, you will get it. That also you will get same answer, you try it. 1284 only will come. My idea was ultimately you are storing cylinder wise only. If you know cylinder size, to hold this much file size, how many cylinders is required? So that is only point we can solve it. Yes, it is clear. Chalo, we'll move on to other topic, instruction set, architecture and instruction pipeline. Very important thing to be discussed here. So 2 topics we are going to be covered, instruction set architecture. So instruction pipelining, okay. So now here under instruction set architecture, what are the things, machine instruction formats. So machine instruction format, right, machine instruction format we see, followed by encoding is very much important, encoding, and other thing just you study like execution part, instruction execution part, you might have studied that, follow it the number of stages how they are doing, that's it. And other thing we have to know, addressing modes, various addressing modes are important. Theoretical questions can come or even practical questions like numerical type questions also can come from this one. Okay. Machine instruction format, encoding, instruction execution, addressing modes need to be covered from this one. I will later I'll take for this one. So after this one only. Okay. Now what is a format, please? What is the machine instruction format as? Machine instruction format, essential fields are, what are the essential fields we have? One is opcode, isn't it? Opcode or operation code. They're followed by addressing mode field will be there. Then operand fields we have, right? Operand fields we have. This is type of instruction. Let's take add, it says add or store, like subtraction, whatever instruction you are writing now. These are instructions or opcodes also we can tell. This will decide which addressing modes are kept here, which addressing modes are kept here, which addressing modes are kept here. Operands are can be single operand, multiple operands. It can be memory operand, register operand. The way operands are represented in the instruction completely depends on the various addressing modes on various addressing modes. If any architecture is supporting more number of addressing, nothing but more flexibility that architecture will provide it. Okay. So as we know the things, one point if you see program is there, okay. Program, please understand, program as so two things is there. One is code section, set of instructions, isn't it? Code section. Other is what? Data section will be there. Data section can be what? Static data, isn't it what? Dynamic data. Am I right, all of you? I hope you know about static and dynamic. Static nothing but size of the program not going to be changed, either not increasing or not decreasing. I know the size of the variables or size of the data sets I know before runtime only, that we call static data. Now in the memory image of program, if you see somewhere code section is placed, code or text section also you can say. Now some data section will be there. What is the data section? We call a static data section, which is not going to be changed place state. Now dynamic data is placed, dynamic data also we call heap area, also we can call heap area. This is growing here, but essential data structure we should assign for running program will be the stack also can grow, Now look the point, role of addressing modes. Code section can I handle with the program counter, please understand. Stack data can I handle with SP stack pointer, I can handle it. Now this data, either static or dynamic data, I am handling with what? Reading, writing with happens for various addressing modes only. Through addressing mode only I can do it. Now addressing modes are helping to represent or interpret the operands in the instruction field. Instruction like this. Operand can be a register operand, maybe memory operand, that is given by various addressing modes we have. Right. So this instructions which you know, the instructions we know like it can be data transfer instructions, data manipulation, arithmetic logical shifting operations, program control instructions like branch instructions, those two little revise it. Okay. Now we have a architectures or addressing instructions addressing instructions we have. So you might have studied like one is 3 address instruction, 2 address instruction, 1 address instruction, 0 address instruction, isn't it, all of you? This is studied all of you. 3 address, 2 address, 1 address, 0 address. 3 address means 3 references for operand, 2 references for operand, 1 reference for operand. In case of 0 address, no reference here. So this is handled by what? Stack, correct or no? Memory stack. So stack operation based also sometimes our questions are framing, sometimes questions are framing So we use some polished notations like postfix notation to evaluate the expressions. In case of stack organized computers we can say, or 0 address instruction based architecture also we can tell. Naturally all the formats are broadly classified into 3 types of architectures. One is general CPU register organization, so that is supporting these 2. One is single accumulator based, isn't it? Single accumulator based architecture. The third one is a stack organized computers also we can tell. This is one thing here, okay, this is one thing. So that is the theory part. So now no much numerical question can be seen, but under encoding nothing but some architecture will support more than one addressing. Some architecture supporting what? More than one, maybe supporting 0 as well as 1. So 1, 2, 3, 4, 1, 2, 3 like this can be supported. So with this one, many times question framed, in 2024 also there was a four questions framed on this area. So little interesting part we need to learn from this one. Suppose one instruction set architecture is there. This instruction set architecture, or you can call instruction register, or you can call instruction format also assumption. So this says, let's take example, I am taking the scenario, 16-bit architecture I am taking. Listen carefully 16-bit architecture it has, okay. Maybe this architecture supporting 0, 1, 2 addressings. 0 supports, 1 support, 2 also supports assumption now. I may be using address bits, or let's take address bits, or 4 bits are used. 4 bits are used. Now we have to formulate how many 1 address possible, how many 0 address possible, how many 2 address possible. With this one we want to know. Now can I say one thing, number of 0 address instructions, if I want to ask you, is it possible 2 power 16 only? Please answer. Number of 0 address in the address instruction, this will support 2 power 16 or not? Any doubt is there? Alone. Yes or no? Respond. Number of 0 address instructions supported by this architecture 2 power 16. Suppose second one, number of 1 address instructions. 1 address instruction supported by means 1 address nothing but address 4 bit will go. If 4 bit will go, remaining what 2 power 12 possible, is it not? Alone all. When it is supporting, this won't support like this. Similarly, if I want to say number of 2 address instructions supported by this architecture will be how many now? 2 address means what? 4 plus 4, 8 bit removed. So 8 bit removed nothing but 2 power 8 possible. Correct? Alone 2 address instructions, alone 1 address instruction, alone 0 address instructions are referring. But I want to make it combine them. I want to support all of them. How to write the equation? How to write this expression? Look this properly, ma. Generally student have a confusion here. So 16 bit architecture I am taking, right? So I am configuring this thing into what? 1 address also. Address bit same example I am taking as 4. Here full opcode of 16 bit. Here 4 bit address goes means what? Opcode will have how many now? 12 bits only will be there. Now further I am making what? 2 address instruction, 4 address. So opcode will be what? 8 will be there. This I am dividing like this, So this I divided like this, understand now. Architecture as 0, 1, 2. Now listen carefully, all of you. Number of 0 address is possible, 2 power 16 possible number of 0 address instruction, no doubt on that one. In order to support 1 address instruction, 4 bit you have to take it here, address part. 4 bit nothing but 2 power 4. 2 power 4 instructions you removed from what? 0 address. So therefore this is possible here opcode. In order to make 2 address nothing but again from 12, 4 bits you have to take it. So 4 bits you have to take it here. So 2 power 4, 16, 2 address instructions are removed. So with this respect, I want to write the expression 2 power 16 equal to, I can write P, please observe now, P. What is the P? What is the P now? P is what? 0 address instruction. If I want to support Q, so I am naming as this is a P, I am naming as Q, this naming as R assumption now. If I want to support 1 address instruction, I need to remove what? 2 power 4. See, 2 power 4 weight I am adding nothing but this is one address, only one instruction you taken, this many bits removed, now this much weight is removed, correct or not? In order to support 2 address instruction, 2 addresses I need to write it like this. So now P indication 0 address, right? 0 address instruction. Q indication what? 1 address instruction. R indication what? 2 address instruction. Now with this help, any type of question you can solve it, ma. Related any type of question can be solved it. So they will give PQ, or they can ask QR can given, P can ask like this, isn't it? It makes sense, huh? Anybody having doubt in this moment? I will rewrite with the other part also. 1, 2, 3, sir. 1, 2, 3 if it is supported, how to write it. I will take that part also. Right now it is clear, everyone. Now just memory address taken like 4 bit only. Even other address also can have, registered address also can have. Registered address also can have. So now let me take one more example. Suppose I am increasing this. So 32-bit instruction set architecture is there. Okay, 32-bit instruction set architecture is there. I am taking now. It supports, it supports. I am writing 1, 2 and 3 addressing instructions supporting. And address bits are 8 bits given. Memory address bits are 8 bits given now. It is supporting what? 1, 2, 3. 1, 2, 3 writing. How to write this one, I can write, So now 2 power 32, P I am writing as 1 assumption. P means what? One address. One address, if you want to support nothing but one address should be there. Na? You write that address. What is the address? Sir, 2 power 8. Write like this. One address, right? So now Q is there. Sir, two addresses, nothing but what? 2 power of 8 into 2 power of 8. 2 power of 8. That's nothing, 2 power of 16 only. Two addresses are there, this one. Sir, 3 address also, sir. It's a 2 power 8 into 2 power 8 into 2 power 8. You have to write it. So this way, if you formulated any parameter given, other parameter easily we can able to calculate. One address. Or else can I write this one also? So I am writing 2 power of 24, I will write it. So 2 power 24 equal P, I will write it. P plus. P I am indicating, sir, suppose your minimum address is how much will go, ma? 8 will go na. Sir, this one address instruction, sir. In one address 8 will go, sir. Opcode will be 24, sir. That I am writing for this one, 24 only. So 2 power 24 one address instruction possible, isn't it? Plus, if you want to support 2 address, so 8, one more extra 8, 2 power 8 bit required. If you want to support R 2 power 16, I should write it. Both are same or not? This expression both are same or different? This fully writing, now fully all possible instructions I have written, in which addresses I mentioned. Now in this case I have taken first one address, thereafter written 2 and 3. Otherwise 2 power 8 you can take in common all of them, this only will get na. Required response every one of you, required response. If you understood well this one, question solvable, easily solvable. All the questions related to this one is solvable. Yes. Are they both same or different? Tell me everyone. Both same only. Mathematically 2 power 8 take a common, you can write this one. Sir, this will take less time to compute, sir. This will take lot of 2 power 32 value should write, that's the only thing. They reduce your time, it will increase the time, that's it. Both are same only now. But my idea is I did not take in common, I written directly, sir. Minimum address which support one address I written, address bits allocated. Sir, with a 24 bit how many one address possible, sir? With a 24 bit how many one address possible, sir? 2 power 24 possible, sir. Sir, in order to support 2 address, one more address I am adding here. One is default is there. So to address 3 address, this is what 3 address instruction, 3 address instruction. So this is what 2 address instruction, 2 address instruction. So this is what 1 address instruction, 1 address instruction like this. Both are same only. Both are same only. Now, sir, in case of address, it can be more than one address also. Are you getting? More than one address also. It is not always memory address also. It can be registered address also, right? Registered address also can be there. Registered address also can be there. Let's take one example I am taking. One more example I am taking now. Suppose there is a instruction set architecture is there. It is supporting 2 type of instruction. I type and R type instructions are there. Please. So this has 16-bit 16-bit instruction set architecture is there, supporting I type as well R type. Please understand. I type and R type. Please. Now I type has a form. Opcodes will be there. Opcode plus. So register, you understand, register operand 1. So register operand 2 is there assumption now. Operand 2 is there. R type has opcode will be there. One operand field is there, register type 1 is there now. So number of general purpose registers, let's take 16 are there here. 16 are there now assumption now. Now I type opcodes are, let's take I am taking 2 power of if I take 448, 8 means okay. Let's take 16 are there now. How many R type is supported I am asking now. There are 16 opcodes are there which are I type. How many R type opcodes are supported by this architecture I am asking now. What I can do it, look this. 2 power of 16 is a total number of instructions, isn't it? 16-bit nothing but 2 power of 16 total number of instructions possible, which includes what? I plus what? R type also, isn't it? Am I right, all of you? Sir, if it is I is supported, sir, if it is I is supported, I should know addresses na. This I type, sir, addresses nothing but register address, right? How many registers are there, sir? 16 registers are there. To fetch one register, how many bits required, sir? There are 2 fields are there, sir. So 2 power 4, 2 power 4. Can I write? Now, sir, R type is there. R type having only one register operand. Can I write like this? 2 power 4. Amma, is it clear? The way it is writing clear? Each one of you tell me. Each one of you tell me. It is very important. I am telling you, it is very important to know this. Yes. Now 2 power of 16 equal to, this is 16 is there into 2 power of 4 into 2 power of 4 plus R into 2 power of 4, isn't it? Now can you tell me R value? Can you tell me R value now? Calculate and tell me now. All of you. Quickly calculate and tell me. Yes, everyone, those who are watching. So what is R value? Yes, yes, what is the answer? It's a normal operation only, right? $3840, 65,536 minus this value 4096 divided by 16, correct? So this R value equal to 65,536 minus 2 power of 4 nothing but 2 power 12, 4096 divided by 16. All of you, what about Hamad? Yes. So 3840 is right. Amma, that value if it is right, no, I can write, I am writing just whatever you given calculation I am using. So other people can verify this only answer, like we can calculate and get it right. Can you answer this question, all of you? Quickly, can you answer this question now? Take the screenshot first here, you try it. Same way you try it, you tell me the answer now. Take the screenshot first. So by the time I will write other things. A processor has 16 integers, 64 floating point registers are there. It uses 2-byte instruction format. There are 4 category instructions, type 1, type 2, type 3 and type 4. Type 1 category consists of 4 instructions, each with 3 integer register operands. Type 2 category 8 instructions, 8 opcodes, each with 2 floating point operands given. Type 3 category 14 instructions, each with 1 integer operand and 1 floating point operand. Type 4 category contains n instructions, each with a floating point operand only. Then the value of n is possible. What is the maximum value? They are asking. Can you please formulate and answer it? Yes, yes, try. Try ma, try. Have you taken a screenshot? This was asked 2018 paper for 2 marks. Yes, yes. Quickly do it, ma. Okay. Yes, yes. What is the answer? 16-bit means what? 2 power of 16 equal to type 1 plus type 2 plus type 3 plus type 4 we can take it, correct? Type 4 we can write it. So 2 power of 16 equal to type 1. How many supporting? Just a minute. Type 1 category consists 4 instructions each with 3 integer registers given. 4 instructions, 4 into 2 integer registers, 3 integer with 3 operands. Integers are 16-bit, 16 integers are there, nothing but. So 2 power of 4 into 2 power of 4 into 2 power of 4, meaning 3 operands fields are there, this meaning. Plus type 2 as type 2 category consists 8 instructions with each with 2 floating point registers. Floating point has 64, 6 bits required to address them. 8 are there. So 8 into 2 power of 6 into 2 power of 6, 2 operands are there, 2 addresses are there, right? So see, there are type 2 category consists 8 instructions, each with 2 floating point are there. Type 3 consists 14 instructions, each with 1 integer operand, 1 floating point. 14 are there, these are 14. So 14 into 1 integer, 1 floating. Type 4 has n instructions. Type 4 has n instructions, each with a floating point register only 1 floating point register. That takes what? 2 power of 6 value. Can you calculate n value now? Simplify, you will get answer. Just simplify, you will get answer now. Simplify it, you will get. So this answer, if I am not wrong, this will get 32. Will get for 32. Will get 32 here. Done. You can try. So next question is that you understand this question, you can try it. It is related to call instruction. Related means, try to revise the, yes, 32 answer, right? Try to revise the, branch type of instruction execution, like, very good, very good. Branch type of instructions like call subroutine instructions will be there, na? Like a stack is growing upward, downward, based on that concept is there. You try this homework, ma. So this question you must to try. This question was asked in, if I am not wrong, this was 2017 paper or some paper you asked, ma. So this question you can try it. Based on the stack information can be done. So now we'll quickly move for instruction pipeline things, because it is very important to be discussed here. Okay. In which what are the things to be noticed, we'll observe here. First and foremost thing you should know, speed of factor. The speed of factor we measured what? Time with non-pipeline by time with non-pipeline by time with pipeline. time with pipeline. This is very much important. Always do remember speed of factor always you greater than 1 will get. Speed of factor you will achieve more than 1 will get. Speed of factor will get greater than 1 you will get. Okay. So one more thing, in ideal pipeline clock per instruction average will get 1 in a pipeline. Please understand. Clock per instruction average will get what? 1 in ideal pipeline. In ideal pipeline clock per instruction 1 only we can prove it. This one thing to be noticed. Okay, next. So next, third one. Efficiency, how to get it by efficiency? Efficiency of a pipeline, how to measure? Efficiency generally says utilization by useful time by total time. Now here useful time nothing but speed of factor, achievable speed of factor by one more thing I have to write it here, better I am writing here only. Okay. So speed of factor ideal case, ideal speed of factor will get what? K, where K is the number of stages, isn't it? This is true. Ideal case maximum speed of factor which you can achieve any pipeline will be K, where K is the number of stages. Now fourth point, efficiency of the pipeline achieved speed of factor, normal speed of factor by, so ideal is what? K. What is ideal speed of factor? K. So normal definition, computer networks you might have studied, useful time by total time. Transmission delay by total time is a sender efficiency. Correct? Here is what? Useful time nothing but utilized speed of factor by ideal speed of factor. This is what efficiency you can understand now. The fifth point, throughput they can ask sometime, throughput. Always do remember throughput is measured in terms of million instruction per second. It is simply 1 by average instruction time in the pipeline. This also we can tell or clock per instruction average. If you get clock per instruction average, get the time for a clock, make it in time basically. 1 instruction time in the pipeline, 1 by 1 instruction time in the pipeline will give the throughput. We are generally measuring what? Million instruction per second will measure it. Million instruction per second will measure it. This we know, correct? So other thing, so now efficiency we got. Sixth point you understand now. As we know, clock per instruction average will get 1, isn't it? 1 only. Yes or no? This is correct? 1 only now. If no dependency is there, please understand, if no dependency is there, no dependency among the instruction, no hazards are there, ideal pipeline will get this one. But seventh point you understand, clock per instruction average in the pipeline can increase. So delta clocks can happen now. Delta clocks can happen. What is the delta? So delta defines, what the delta defines, ma'am? Delta equal to like a percentage of dependent instructions, or what you can say stall frequency we can say. Stall frequency into number of stall cycles, number of stalls also we can tell. So number of stalls also we can tell. Or dependency rate into stall cycle also we can define. Average will be 1, it can be go more than 1 when there is a dependency is there. This one thing we have to notice it, correct? Are you getting all the points here, every one of you? So eighth point, speed of factor generally we are getting n into k, correct on, n instructions into average clocks in k into what? Cycle time of non-pipeline divided by what? K plus n minus 1 into cycle time of pipeline. Is it correct? Anybody having doubt here? Suppose program has n instructions are there. If I run a non-pipeline pipeline, if we want to get the speed of factor, n instruction, k stage instruction pipeline. So now cycle time of the non-pipeline by cycle time of the pipeline. In case of pipeline, first instruction will take k clocks, remaining n minus 1 instruction take 1 only. So this we know. Okay, correct. So ninth one, suppose whenever the cycle time of non-pipeline and pipeline is same, so this speed of factor can I write it 1 into k by k plus n minus 1 I can write it. When this pipeline n is very large, k becomes constant, can I ignore or not? So therefore what happens? So nk by n can cancel. So now speed of factor we can get what? Ideal case is what? K, isn't it? This only we proven, mathematical also we can prove it. When n is very large number, so k becomes a constant. K becomes a constant. So one thing, this one. 10th point. Amma, cycle time of NP, non-pipeline, how to measure it? Cycle time. Cycle time, just a minute ma. Please tell me, all of you, how to find the cycle time of non-pipeline. Cycle time of non-pipeline. What is the meaning of cycle time? Cycle time, very simple. When I supply one instruction to the pipe, that stages, it has to get output. So now the instruction has to go all the stages only, correct or not? The instruction has to go all the stages, isn't it? Just a minute. Now see, what I am trying to say, cycle time of non-pipeline nothing but, suppose the stages are there, let's take, stages, okay, stages. This is taking 2 nanosecond, this is taking 3 nanosecond, this is taking 5 nanosecond, assumption now. If I supply one instruction, it will go and it will get output, right? What is the average time will taken by one instruction in the non-pipeline nothing but cycle time of pipeline only. I repeat my statement, amount of time or average time or amount of time taken by a instruction in the non-pipeline is nothing but cycle time. Cycle time you can measure in terms of clocks also, in terms of time also. If it is a time, sum of stage delays you should add it, that's it. Is it clear? Or simply, suppose each one taking one clock cycle in terms of cycles, so you can tell k clocks also you can tell. Either you can tell sum of the delay or k clock cycles also you can tell. K can I tell or not? Just a minute ma, just a minute. One average instruction time. Correct, we can tell. K clocks we can tell, because one clock will go. 3 means 3 stages, 3 clocks. 5 stages, 5 clocks we can tell. Yes. Very good. So no doubt on this one, right? 11th point. Cycle time of pipeline will be always, you understand, maximum of any stage delay plus buffer overheads are present. In case of pipeline, if all stages are same, cycle time will be any stage delay ma. Second point. In a pipeline, if stages delays are different, I have to wait for what? Largest delay, stage, low, like the highest delay stage I have to wait. That's what we are taking, maximum stage delay plus buffer overhead we have to take it. So reason, please, what is the reason? First instruction anyway takes sum of all the value. Second and third will be constant time will be increased or not? Yes or no? Try to respond ma. In a pipeline, when I am running first instruction, all stages plus interstate buffer also need to be carried out. But second instruction will be some constant time, third also constant time. That is nothing but maximum value of any stage delay only. Carefully you have to draw the diagrams, you observe it. You mention delays like 100 nanoseconds, something, you can make it. Then draw your own diagram, try to understand yourself only. Why should I take this maximum stage delay? So this gives simply one instruction time also can tell. One instruction time also we can tell this one. One instruction will come out after this time. These are the important things need to be noticed from this one. Okay. Now come to the point, ajars in the pipelines. Ajars in the pipeline. Ajars in the pipeline. Ajars in the pipeline. Tell me what are the ajars present in the pipeline? Meaning ajar means what? Any condition which affect the pipeline to be stall. Any situation might occur to the pipeline which is stalling. Stalling nothing but not able to continue. That we call ajar. So these ajars are broadly we have three types. One is data hazards. Data hazard. Second one is what? Control hazard. Control hazards. Third one is the structural hazard. Structural hazards. Structural hazards. Am I right, all of you? Am I interesting things so I am going to discuss for a data hazards now. We have to be like a little patience and observe the things. So now this all data hazards occurs due to what? Due to what? Arithmetic operations only, please understand. Due to arithmetic operations only. Due to arithmetic operations. Correct? Control hazards occurs due to what? Branch type of instructions. So branch type of instruction, isn't it? Branch type of instructions. Structural hazards will happen because of our limited resources. Limited resources. Some stages cannot be overlapped at the same time. That's what we have to duplicate. Solution is very simple. Duplicate the resource only there. But these two problems can be resolved. Now these data hazards are classified into majorly, write after read. Second one is a read after write and write after read. Third one is what? Write after write. Write after write. Majorly three. Last one we can say read after read. That is not considered to be any problem. So write after read also we can call original or true dependency. True dependency. Read after write. Read after write we called original or true dependency. Write after read we called anti-dependency. Anti-dependency. So this we called output dependency also we can call. These are important now. So as we studied, I think if we come looking at one by one, if you see one by one, first one if you observe. So data hazards if you observe, we have told now one is read after write, second one is what? Write after read, third one is what? Write after write. Write after write. Example if you see, what is the example? I1, I2 if you take, maybe performing add register R1, register R2, register R3. I2 may be multiplication if you take, let's take example now. I am storing it, let's take R3 assumption, R3, R1 and R4 required assumption now. Read after write, first write operation done, then reading. So now see, can you see now write operation happen I1, which I need like this, this we called what? This problem is called what? Read after write also we can tell now. Write after read, first reading happen, then updating happen, overwriting is there. Can you see now? See this one, this part. Can you see now? This one is called what? Write after write problem. Write after read problem we can tell. So now this write after read, write after write can be resolved easily, right? Can be resolved easily by what? Register renaming. Yes or no? So register renaming. So register rename nothing but you can use another register, resolve it. But this original problem is what? Read after write problem cannot be resolved by like this. Because second instruction depends on what? First instruction result. Second instruction source operand depends on the first instruction what? Result. That results are not yet computed. That may not be available immediately. That is causing the pipeline to stall. So when time is increased, directly effect on the speed of factor only. All of it is clear. It is highly possible to test you giving a number of instructions. They'll ask what are the types of dependencies present among these instructions. They can give some options. So you have to be carefully observe like this. Carefully, successive instructions you have to observe it. If possible, you draw the timing diagram. You see that what are the dependencies are present. You are able to answer like this. So coming into the point, solutions. What are the solutions for data dependency problem? Solutions for data dependency. One is simply stalling. Simply stall it. Second one is what? Compiler based solution, isn't it? Compiler based solution. The third one is important one, operand forwarding. Operand forwarding. Operand forwarding. Correct or not? Operand forwarding. What is compiler based solution? Insert NOP operation, right? Or insert what? Independent instruction, correct or not? First to detect the dependency. If you have two instructions dependent each other, so one it depends on other, find any independent instruction, place it, or simply put it on NOP operation. That way you can solve, but is not efficient. It is sometimes may lead to what? Exponential time. Require exponential time to identify the dependency among the instructions. The hardware solution, operand forwarding is what? Hardware solution through which most of the data dependency problems can resolve. It is not resolving the other problem, other hazards. It is only related to what? Data hazards only. Data hazards. So now question comes, I am asking everybody, does operand forwarding will resolve all data dependency problems? Please answer it. Does it resolving the every data dependency problems? Will it resolve? Will it resolve? Answer it, answer it. Everyone. So will operand forwarding mechanism, will it able to solve all the data dependency problems? Answer is no. Answer is no. Let's observe. Let's observe. Example I am taking. This question is what? So 6-stage instruction pipeline where all stages are perfectly balanced. Assume that no cycle time overhead pipeline. When application executing 6-stage instruction pipeline, the speed of achieved with respect to non-pipeline is dash. If 25% instructions are incurring 2 stalls, the speed of factor. Ideal pipeline, they were all stages are perfectly balanced. There is no cycle time overhead in the pipeline. Now 6 stages instruction pipeline is there. In non-pipeline 6 clocks required, isn't it? Perfectly balanced, nothing but every stage taking one clock cycle only. So 6 clocks required. In a pipeline generally 1 clock required if no dependency. But they said 25% dependency is there which are occurring what? 2 extra clock cycle occurring, isn't it? So now this value is what? 6 by what? So 1.5, isn't it? Now 4. Am I right, all of you? Very basic question, ma'am. But you should know applying dependency, when to apply dependency. Normally clock per instruction 1 only. Due to dependency, clock cycle increase 1.5 happen. So that it directly affect on the speed of factor. It is effect on speed of factor. Come to the point of looking for this operand forwarding. Now look this point, ma'am. Okay. Just I am observing, adding R0, R2 storing R1 register here. R1 register like this. So timings I am given 0 to 200 picoseconds taking instruction fetch, 200 to 400 decode taking, 400 to 600 execution, 600 to 800 memory, and 800 to 1000 picosecond write back. So each stage taking 200 picosecond example I have taken. Listen carefully, all of you. Stages we know: instruction fetch, decode, execution, memory, write back. So now come to the point. Here come to the point. So one interesting thing we have to see. What is the meaning of forwarding? So is it visible by these instructions are visible, all of you? These instructions are visible. What is this instruction? Add R0, R2 storing in R1. This R1 only required. Can you see now? R1 only required. So now instruction 2 depends on what? Instruction 1. So instruction 2 depends on instruction 1. I am running in this one, applying operand forwarding. Let's observe it. Instruction 2 needed R1 at times 600. See, first I fetch instruction fetch, decoded R0 R2, execution happen, R1 available here, right? R1 available here. So but here R0 plus R2 available here. But here is decode done what? R0 comma R2 done here. Now see, second instruction we are fetching what? Fetching like 200 to 400 I am fetching. So now next decode time I need R1 R4. I need what? R1 comma R4 required. But R1 is available end of this what? End of this one available. So that I2 depends on I1. Operating forwarding nothing but what we are doing now. This execution results I am forwarding to another execution stage. You see now. Instruction 2 need R1 at time 600 required. Instruction 1 produce R1 at time 600 produced but not write back here. A new value of R1 has not yet been written in the register file. Result available not written. You understand? Not written. So instruction 2 takes R1 from the ALU output at time 600. This we call forwarding. Instruction 2 takes at end of the 600 it is here. So this case forwarding solve the problem. So we don't need instruction bubble here. No need to insert any bubble. So directly operand forward mechanism is able to solve this problem by forwarding. No extra clock cycles required to be forwarded. But there is a case can happen like this, to understand now. One more case. You see this one instruction is there. What is the instruction says? 20 plus R1 of content memory location you have to load into register R not given now. Okay, R not given. All of you observing or not? You see the point. So clock number 1, I will fetch instruction 1. I am fetching instruction 1. I am fetching instruction 1. Clock number 2, I am fetching instruction 2 and fetching R0 R1. See, instruction decode register read. What are the registers I read it now? R1 I need. I have to compute, right? I have to compute this one, correct or not? So now, so execution time nothing but what? 20 plus R1 I will compute it here. But in the third clock what happens? I need what? R0 I required. Third clock I need R0. See, can you see? R0 required, which is not available. Which is not available. So now fourth clock what happens, you know? I will go to memory access, right? Memory access. I will go to memory and get the operand. End of the fifth clock I am writing back, but end of the fourth clock, content of R not available, means the results available which yet to be write into R0, right? So memory access happen, R being computed here, end of the fourth clock, content which you require to load into R not available. But for this instruction, beginning of the fourth clock only required. This depends on, you see. So now see, the new value of R0 is needed by the instruction 2 at the start of the fourth clock only. But the new value of R0 becomes available from the memory at the end of the fourth clock only. It is available end of the fourth clock. I need it beginning of the fourth clock. I don't have option to forward, correct or not? Why, sir? You know, execution to execution I cannot forward. I don't have execution done, address calculation, not data calculation. I have to wait one more bubble. I have to wait for one more cycle to solve this problem. Therefore, I am concluding. Whenever load, please understand, load instruction followed by some R type of instruction, RISC style type of instruction present. So operating forwarding cannot resolve alone. Operating forwarding plus one stall required to resolve it. So that mechanism you can see now. What I did, you know, same instruction I have taken. I inserted the bubble. You can see now. I inserted the bubble here. One bubble I inserted. Now see. So ALU like address 20 plus R1. This is what R1. This is R1 computed. So memory access done. So because of bubble insertion, now ALU operation performing fifth clock. So by the time available, I can forward here now. That's what I written a point. You know, the new value of R0 is needed by the instruction at start of the fourth clock cycle. New value of R0 read from the memory at the end of the fourth clock cycle. So we stall one cycle, fifth clock cycle we can forward from what you can say year to year, half of the clock. So simply write back stage, execution stage is saying how it will be understand, you know, half so this write back stage is there now. First half you forward, second half write back, like this. Generally you may get confused here, sir, how it is possible to forward from write back to execution stage. First clock forward, second half you write back to register, like this you can do. Simply I am telling load followed by R type is there, load followed by R type is there, operand forwarding cannot resolve, we need a bubble. So I added bubble here. So in diagrammatic way also I am showing, either whenever case you understand R followed by load followed by R type instruction is there, don't fetch immediately also better. There is a structure I am saying, no. Generally I have to fetch it here, right. I am delaying from what 200 to 400 I am delaying, at 400 I am fetching the second instruction. So already one bubble inserted here. So what I am trying to say, either middle insert the bubble or beginning only insert the bubble whenever load followed by R is there. So this is structure which is showing what you can say, I am bubbled here, I will fetch here, I will decode, by the time memory access over, I can forward here, I can continue execution. So this way I can solve the problem, but forwarding does not always prevent a stall. One stall essentially required whenever R followed by load followed by R is there. The conclusion I am showing you, R followed by R. So simple solution is what? Operand forwarding I can use without any bubble. This is a best solution. Forwarding I can use. R followed by R. Load followed by R is there. Solution is that insert one bubble and operand forwarding is there. One bubble plus forwarding can resolve the problem. I hope this is clear. Is it clear, everyone? Is it clear? Tell me, operand forwarding mechanism is clear or not? Every one of you. Do respond. Now, interesting things I want to observe it here. You just tell me, a year is given now. 4 instructions given in the sequence R0 to R8 are general purpose registers. So, general purpose registers. The first register is a result of the second 2 operands are given. Now, the sequence of 4 instructions executed in the pipeline execution processor within the following 4 stages given. So, instruction fetch, instruction decode, operand fetch and perform operation, write back results given. So, instruction fetch, operand fetch, write back take 1 clock cycle each for any instruction. Perform stage take 1 clock cycle for addition, subtraction, 3 clock cycle multiplication, 5 clocks for what? Division. Pipeline processor uses operand forwarding from one stage to other stage. Number of clock cycle required to compute this 4 instructions dash. They are asking. Operand forwarding they used. It. Amma, you tell me, among this instruction, do we have any load followed by R type of instructions? Do we have any load followed by R type of instructions here? No. Therefore, alone operand forwarding, can I resolve all the problems? Can I resolve by using operand forwarding? Yes, we can do it. Whenever such thing is given, no need to draw timing diagram. One shortcut method I am showing you. Simply observe the shortcut method. What you can do it, whenever data dependency problems are there, that is resolved by the operand forwarding mechanism is given. So draw the tabular form in which you mentioned what are the instruction we have: multiplication, division, addition, subtraction, right? I am writing multiplication, so division, addition, subtraction is given. Addition, subtraction given, right? Subtraction. This side write the instruction fetch, stage names write down, instruction fetch. Stages are, where the stages ma? One is instruction fetch, decode, operand fetch, perform operation, right? Operand fetch, perform operation, write back given now. So now we have to fill the table with the clock numbers. So easily we can solve it. Observe, observe. How simply can be solved it? How simply can be solved? Everyone do observe. Everyone do observe. Now see some information given, you know. Read it. Instruction fetch, operand fetch, write back. Take one clock cycle for any instruction. One only taking. Let me write it. Instruction fetch, operand fetch, write back. Taking one clocks taking. Clear? Now see. Perform stage take 1 clock for addition subtraction. Addition subtraction takes 1. Now 3 clock cycle for multiplication, 5 for division. 3 clocks for multiplication, 5 for division. You fill it like this. Meaning what I am trying to say, whenever R followed by R is there, operand forward mechanism is then nothing but it is resolving the problem, nothing but all our instructions are independent only became. Such cases, if I want to run, please, after fetch will do, after instruction fetch, operand fetch will do, right? So means 1 plus 1 was end of the second clock, this will over. 2 plus 3, 5. End of this one, it will be 5 plus 1, 6. But this is clear? I means write back will complete end of the 6th class, I am telling. Write back is completing end of the 6th clock. Any doubt is there? Any doubt? Now, come to the point. If you want to perform division of instruction fetch, after multiplication fetch only have to do, right? So the 1 plus 1, I am writing 2. 2 plus 1, I am writing 3, 4. Meaning, end of the 4th clock, subtraction of instruction fetching will over if you draw the timing diagram. You draw timing diagram, same thing will be there. Okay. So now, row updated, column updated, row updated. Remaining cells you update, you will get the answer. How to do it, you know? Maximum of this 2 value, what is the maximum of this 2 value? 2. So 2 plus 1, how much? 3. Maximum of these 2 cells, 3. 3 plus 1 what? 4. Maximum of these 2 cells, 4. 4 plus 1, 5. Like this, you know. These 2 cells again. So this updated value take it. So maximum of this 2 value, 5. 5 plus, add this one, 10. Maximum of this 2 value, 10. 10 plus 1, 11. Maximum of this 2 value, 11 plus 1, 12. Similarly, maximum of this 2, 10 plus 1, 11. Maximum of this 2, 11 plus 1, 12. So maximum of this 2, 12 plus 1, 13. You draw timing diagram, you will get a 13 only. You check it, verify. You take the question, you can take the question. This question was, I'm telling you know, question number 2015, set number 2, 2 marks question. You can note this question here and work out later ma. By drawing the timing diagram, you will get answer same only. Same answer will get it. So this shortcut method I can use to what? Solve the problem, because timing diagram generally takes time to be draw and count the number of clock cycle, right? When to use, sir? Whenever tabular form clock cycles given, use this one. Whenever operand forwarding used, having what? Not load by R, only having what? R by R type of instructions. Successfully can use this tabular method to solve the question. I hope this is clear, everybody. Everybody, it is clear. Is it clear, all of you? Everyone, do respond. Do respond. Hamad, Namana. Can we answer this question now? Very interesting question now. So A equal to B plus C, I want computing. C equal to B plus F is computing. Okay. Now see. So now load be written how? No, LW means load instruction ma. Load, add, store is there now. So I hope you are understanding. Memory location at index addressing. Which addressing mode might one? This one, which addressing mode? Is it not index addressing mode? In this location data is there, you have to load R1. So in this location data is there, load it R2. R1 plus R2 storing in R3. So in this location data is there, loaded R3. Then store, this is store, first store into memory location, because B plus E store into A happen now. Now I am taking like this, understand? Somewhere my memory location 0, followed by 4, followed by 8, followed by 12, followed by 16, like this are there. At 0 location we have B value. At 4th location E is there. At 8th location load a word, F is there. 8th location F is there. At 12th location A is there. 16th location C is there, like this. These are the memory locations data, isn't it? Now identify all the hazards in the code. Which one can be resolved by forwarding? Which one cannot be solved by forwarding? Can you tell me what are the dependency problems are there? Let me check. I am going to take this question, take the screenshot, we'll answer it. Very interesting question. It will resolve lot of doubts. Solving this question will resolve a lot of doubts. All of you note. Noted? Everyone noted? Yes, ma. So I'll take I1, so instruction 1 I am writing, instruction 1, instruction 2, instruction 3, 4, 5, 6, 7. I1, I2, first thing, instruction 1, instruction 2. Do we have any data dependency? It is taking loading from year to year, right? No data dependency. No data dependency I am taking now. Second one, I1, I3. What type of data dependency is there? I1, I3. So we need R1, correct? R1 is coming from here only, isn't it? So I can tell it has read after write problem, isn't it? Am I right, all of you? No, see, I am reading now, after writing reading, correct or not? So I1, I3 having problem, Now I2, I3 also having problem, right? So third point, I2, I3 also having which problem? Read after write problem only there, isn't it? You see? So we are reading R2, it is updated by this one, correct or not? R1 is here, right? So this R2. I3 depends on I2. Even I3 depends on I1 also. Which dependency we have? Read after write. We don't have other dependency, correct? This is done now. Next, fourth instruction if you take, I2 to I3, we are reading R0 here, R0. R0 comes from where? Initially, no problem. R3 is what? R3 we are storing, correct or not? Amma, you are not updating. Store a word not in this location, content of R3 you are loading, correct or not? So therefore, I am just comparing fourth point. So I3, I4, if you see, what dependency is there? I3 to I4. I4 to I3. We need R3. Results I need. Source. First write, then read, correct or not? So now it has a problem of what? So write after read problem. Am I right? Tell me, everyone. I3 to I4. So now see, I am storing in this memory location. See, write A to memory saying na. Content of R3 you store in this location, right? No, here, in this location you have to store it. So now R3 required from the previous instruction only, right? So write after read is there now. Load a word. So we need R0, we are loading into R4. So we do not have anything. So now here is required what? R1. R1 is required from first instruction. R4 is required from what? Load required, load nothing but, yes, this is depends on this one. So I am saying that, now I am writing, come to the point here. Now, The fifth point I can observe I4 to I5 if I see I4 to I5. I4, I5 if you see loading and this is storing, no dependency. So I am writing no dependency. Sixth point I4 to I6, do you have anything? I4 to I6. So we are adding R1 plus R4, R1 has to come from there, R4 has to come from what? 6. So no relation from this one. So no relation. But seventh point to understand, you know, seventh point to understand, we need R6, right? So we have a dependency I1 comma I6 have a dependency which one? Read after write is there, isn't it? You check, no? See, we need R1. This R1 may not be available because end of the memory access will get. You draw the pipeline, you will get, definitely will get a read after because I am reading after write, correct or not? I6 depends on I1, read after write problem is there. And also this required here. So 5, 6 also having the problem. So 8th point, okay. 5 comma instruction I6 also having problem what? So read after write problem is there. See, R4 is coming from here only, right? After loading this has to take, correct or not? This loading here reading, correct or not? Now R0, this is R5 you are reading, correct or not? R5 value you are reading, store a word. R3 also you are reading from here, right? Reading only, reading. So I3, I4 I have problem, right? I3, I4 did I write? I3, I4, yes, we have a problem. So we are required what? R4 required, no, 6 and 7 also having problem. 9th point, I6 comma I7 also having problem. I6, I7, what problem? We need R6 source, correct or not? Source you required, we are writing, no? Store, sorry. Write after read is there, no? First write, then read is there, right? First write is there, then read is there. So it has a problem of what? Write after read is there. Amma, is it clear, correct? The way things which are written? Every one of you please respond. The values are correct? Required response. Everyone do respond. MSQ question can possible. So what you can do, so you have taken this question right, you draw the diagram, timing diagram you draw. Timing diagram you draw. Now second question is that which one can be solved forwarding, which cannot be solved forwarding. So these problems are there. Load followed by add, can I solve with operand forwarding? Just observe the timing diagram, you draw and observe it, I am telling you. No, here load and add is there, I need R2 here, right? These two are, can I resolve with only operand forwarding? Not at all possible. We know now, we studied now, load followed by R type is there, we need one stall plus operand forwarding. So this cannot solve it, correct or not? So one more is also load followed by, you know, R4 required. Here also load followed by R is there. Can you see? Load followed by add is there. These two instructions cannot be solved by what? Only operand forwarding. We need one stall. You draw the timing diagram, verify it. So rest of the instruction I can do it easily. Because the storing means I have to read only. Forwarding I can read it this one. Yes, very good. This way you have to observe the things, ma. So with this I am telling you most of the data dependency problems or whatever types of questions, you know, we are able to solve, because rest of the question which you solved in a PYQs now all covered, you know, many things. I hope this might have confusion, right? I hope this might have confusion for identifying the type of operands, type of dependencies, as well as whether forwarding, not for, like forwarding with a stall, without stall. This is a little confusion will be there with the students. Normal rest binding, speed of factor, efficiency, clock cycle, that all normal things. Lot of PYQs are other questions you might have solved, clarity might have got it. I am literally telling, I know the where people will face the challenges. This is the biggest challenge you can understand now. I hope this is clear. I am strongly recommending every one of you for this example, draw the timing diagram, Make yourself comfortable, make yourself comfortable, ma. Make yourself comfortable. Make yourself comfortable. Yes, it is clear. Everyone clear? Chalo, move on. Now, one branch related question is there now. A processor X operated at 2 GHz has a standard 5-stage RISC instruction pipeline having average clock per instruction 1 without any pipeline hazard. Average clock per instruction is 1. Wait, let me go back. What was your statement? Statement was I3, I4 isn't be right after right. I3, I4, I3, I4. Not at all, please. It is addition, it is a store word, ma. Store word. Store word nothing but nomenclature. You understand what is the nomenclature? Content of R3 loading memory location 12 plus R0. This is the source operand. Please understand, this is source operand. Source operand is not destination. That is a confusion will be there. Store a word, add a word is there, that is different instructions. Is not a problem at all. It is not right after right problem. I hope it is clear. Come to the point here. So for a given program P that has 30% branch instructions, control hazards 2 clock cycles for every branch happen. A new version of the processor X to operated at the same clock cycle frequency as additional predictor is a branch predict unit is there. That eliminate the stalls for correctly predicted branch they are saying. There are no neither saving or nor additional stall for wrong prediction. There are no structural hazards and data hazard for X1 and X2. If the branch prediction unit is predicted accuracy 80%, what is speed of factor with X2, X1, X2? Like nothing but what is the speed of obtained by X2 over X1 is dash they are asking now. So speed of factor is nothing but, so X1 by X2, this way should write it. X1 is the processor, X1 is one of the processor having 5 stages pipeline. Having how many? 5 stages are there. Okay. You get the one instruction time, one instruction non-pipeline, one instruction if I want to compute. What they said here, clock per instruction 1 only they said without any pipeline hazards. So now non-pipeline we should not take, pipeline only should take, this only pipelines only now. So they said 1 clock cycle only, 1 clock only. So what is the 1 clock time? 1 clock time are they given any frequency? 2 GHz. So can I take 1 clock cycle time? 1 into 1 by 2. This is nothing but 0.5 nanoseconds. Any doubt is there for I1? X1, average clock per instruction is what? 1 clock. Cycle time is what? Just let's just say no. This is 1 clock you take normally. Let me make it here. But they said one point they said here. What is one point they said here? A program P has 30% branch instructions, incurring 2 stall cycles for every branch. So now new version given, that is X1. So when there is a branch, so additional penalty happen, right? So now they said 30% branch instructions are there, 30% branch instruction which incurring what? 2 clock cycle. So 0.6 clock cycle required, isn't it? So 1.6 into clock time is what? They given here 2 gigahertz nothing but 0.5 nanoseconds. So 0.5 nanoseconds. So 1 by 2 nothing but 0.8 nanoseconds comes for X1. Any one of you tell me? Very good, Ahmad, very good, Ahmad. X1 got, answer we got. So X2 saying that, what is the X2? It is an alternate design. X2 has alternate design. A new version of the processor X2 operating same clock frequency, but additionally what you have? Branch predictor unit is there. So this eliminate the what? Predicted branch eliminate the correctly predicted branch. If the wrong prediction is there, no additional penalty, no minimal also, no saving, no extra penalty, they said here. So now let's tie. So we have 30%. So normal in this case also clock per instruction average will be 1 only, but there are 30% branch instructions are there. Out of 30% branch instruction, so branch predictor they used it. They use what? Branch predictor, right? They use our branch predictor mechanism they used. It is predicting what? 80% it is predicting. It is predicting what? 80% here. So 80% predicting. Okay. So 80% what? Predicting nothing but what? No penalty here, isn't it? So 20% are wrong prediction. So when the wrong prediction is happened, what they told, either increasing, either nor increasing nor saving, same penalty only will be there, 2 clock cycle which they given here. So 1 plus 0.3 into this value 0, so 0.2 into 2. What is this value? Can you tell me? Correct this formulation? The formulation is correct, all of you. What I am saying, 80% accuracy predicting. When prediction, no penalty generally. If misprediction, generally penalty will be there, but they said in the question, no additional penalty. That means existing penalty 2 clock cycle only should take it 20% of time. Is it clear, all of you? So this gives what? 1.12 clock cycles. Clock frequency is what? Same only. They said 1/2 gigahertz only. That is nothing but 1.12 into 0.5 nanoseconds. What is this value gives? What is the value giving is this one? 0. What is this value will give? Tell me this value. Therefore, what I can do it now, speed of factor equal to x1 by x2. x1 we got 0.8 nanosecond by this one. How much you got for this one? So 1.12 into 50.5 nanoseconds. Yes, respond. 0.56 nanoseconds. So therefore 0.56 nanoseconds, if I divide it, cancel this value, tell me now. 0.8 by 0.56. What is the value getting? What is the value it is getting? Yes, respond. So 1.428. So now range will be 1.42 to 1.43. You can see. But obviously the gate question they given 1.4 to 1.45 given a range. You can enter 1.4 to 4 the correct, 100% right. So this way you can answer. I am suggesting that focus more on like control dependency problems also. So this part over. From control unit, what you can do, basics will be there. No? You might have studied fetch microprogram, operand fetch with a different addressing mode. Like this you study. And when it comes to addressing modes are theoretical concept. Go through each addressing mode, identifying the addressing modes. This type of questions can be asked. You observe that one. Okay. From IO point of view, majorly, DMA controller. One is a DMA controller, like they ask questions are very straightforward questions can be asked in a DMA controller. What is the question they are asking? Percentage of time DMA is blocked, CPU is blocked due to DMA transfer. Percentage of time DMA is contributing, very standardized expressions are there. So that problems related to practices, that is sufficient. So these are the major discussion from this subject. I hope you enjoyed. I hope this definitely helping you a lot. Similar way I am telling you, try to register for zero fee program and also experience the same way for other subject revision also, like it is very very soon, like I think after tomorrow or day after tomorrow, schedule already done. So you can register, you can also watch what other sessions. Okay, I hope it is clear. So if anybody having a doubts, let me know. Otherwise we can stop the session. We have spent good amount of time only, almost 5 hours time is spent. Might have enjoyed also all of you. Okay, yes, anybody having any kind of queries? Hamad, Prabhava, Namana, if all of you please understand, if you really like this session, you just comment on the video also, so that other people can go to this video, no, that will help for other aspirants also. Sometimes people watch the videos through what comments only, correct or not? Okay, fine ma, we'll stop the session. All the best all of you. So utilize this time in a better manner. Next exactly we have a how many 20 days, 20 days we have around 20 days are there. Utilize properly ma. All the best all of you, all the best.